Okay, good morning, everybody. It is 9 o'clock on the dot, so we need to get this train rolling and try and keep things on time so that everybody can get to where they need to be on the day. We appreciate everybody that's here in person for being here and everybody that is on the WebEx for joining us for Texas RE's first ever grid transformation workshop. This is something new for us. We did our Extreme Events Resiliency Workshop last fall and got a lot of great feedback from that. So we decided to bring it back and do the Grid Transformation Workshop to talk about other issues that are important to the reliability of the grid. So my name is Matt Barber, and I'm the Manager of Communications and Training, and I just have a few housekeeping items to go over with everybody before we get going for the day. Josh, can you put the slides on the screen down here? Apologies for that. So main things I'm here to do today are just make sure everybody knows how to stay safe and how to ask questions and everything that we need to do to get through the rest of the workshop. So first thing first is our antitrust admonition, which will be on screen here in just a second. There we go. That's me. Antitrust. Texas RE strictly prohibits persons participating in Texas RE activities from using their participation as a forum for engaging in practices or communications that violate antitrust laws. Texas RE has approved antitrust guidelines available on its website. If you believe the antitrust laws have been violated at a Texas RE meeting, or if you have any questions about the antitrust guidelines, please contact Texas RE's General Counsel. Notice of this meeting was posted on the Texas RE website, and this meeting is being held in public. Participants should keep in mind that the listening audience may include members of the press, representatives from various governmental authorities, and industry stakeholders. There we go. Safety. Safety is important. Everybody here deals with safety in some way, so in case of emergency today, there are 3 very convenient exits from this room to the sides and back. If an oxygen mask falls, be sure to put it on any kids next to you before you put it on yourself. Any of you that travel, I appreciate you getting that joke. But otherwise, just follow Texas RE personnel. Our rally point is out in the parking lot, and good luck finding some shade if we do have to go out there. Questions. So one thing we've been really trying to focus on since we've been doing the hybrid format, more specifically, is making sure that everybody has an equal chance to ask questions. We know all of you that are here in person, and we appreciate you being here. The tendency is to kind of want to raise your hand and ask a question, but please try and use Slido. We direct everybody there so that all of our attendees that are on the WebEx and here in person kind of have an equal chance to get any questions asked. We will try to get to questions at the end of each of the panels. Please keep in mind that the panelists have a lot to say, so if we don't get to questions, please forgive us. But if you definitely want your question answered, do enter your contact information, because you can keep it all, anonymous if you want, or you can give us your contact information, or just simply send us an email at information@texasre.org, because we do want to answer your question, but just please understand that we kind of have to stay on time throughout the day, because many of our speakers do have flights to catch and things like that. So simply, just if you go to Slido and enter participant code TXRE, or use the handy dandy QR code, and we'll have that on screen throughout the day. So that's how you can get to Slido to be able to send us any of your questions. If you like today's agenda, speaker bios, descriptions of the workshop, descriptions of each of the panels, those are on our website. Just go to the home page and click the big banner that says Grid Transformation Workshop, and then that will take you to this page, and you will have all of that information there. And once the recording is available, that's also one place where we'll post the recording, and also on our training page, which I'll speak to here. So all of our materials we do in our workshops and our webinars, we do record those, and we do put those on our training page, but they are subject to our legal department's retention policy. So just keep in mind that they're not always there forever. It's a period of time, but while they are available, they are here on our training page on the website. Social media is super important. We put a lot of information out there about our upcoming events and other important reliability matters, reports, anything that we think entities and our stakeholders should know about. For those of you that are super social media savvy, we're not on Threads yet, so sorry about that. But if we see that it's important, we may end up going there someday. And I think I've hit all the important points. If there's not any immediate questions, Then at this time, it's my pleasure to introduce Texas RE's Vice President and Chief Operating Officer Joseph Younger for some opening remarks.
Thank you, Matt. Good morning, everyone. My name is Joseph Younger, and I'm the Vice President and Chief Operating Officer here at Texas RE. And I want to thank everyone in the room and online for attending what's really a signature event for us. And I want to start by kind of talking about a little bit why we're here and why we're talking about this topic. In a sense, the planning for this workshop really began on the afternoon of June 4th of last year, when a surge arrestor fault on a 333 megawatt combined cycle unit tripped offline. What we saw that afternoon was frankly alarming. Over 1,700 megawatts of primarily solar-based inverter resources unexpectedly reduced their power output. And that was due to the protection controls at each of those sites. And while this wasn't the first such event that we've seen, in fact, I believe it was the 6th event across the ERO that had those characteristics, the magnitude of this event last year was unique. It was the first time that we crossed what we term an event 3A threshold. So it represented for us a real clear call to action that we needed to address the reliability risks that we're seeing that are associated with what's a rapid and ongoing transformation of our grid. And this is only becoming more acute as IBRs increase in importance for our interconnection. You just have to take a quick look at the ERCOT capacity and demand report to see the impressive and remarkable growth of inverter-based resources in our interconnection. And I was just looking at the ERCOT dashboards this morning, and they're forecasting 20 gigawatts of IBR generation, wind and solar, including about 12 gigs of solar, to meet our peak demand today. So it's an incredibly vital and important resource for our interconnection. So managing the pace of this transition and ensuring that we have the right performance standards so that we can have reliable electricity while encouraging these resources and their growth and all the positive attributes that they bring, it's one of, if not the most critical reliability challenges that we're all collectively facing. So that's why we're here today. Turning back to the report that our staff and NERC put together over the past year, there's a number of recommendations like there are in all of our reports. And I think you can divide the recommendations that are in the Odessa report into 4 broad categories. And it's no surprise that the panels that you're going to hear today in large part are informed by those recommendations. First, our joint report stresses the importance and need for more rigorous and accurate modeling requirements to identify and address reliability performance issues. These include developing standards around new modeling requirements like EMT, but also simply addressing to make sure that the as-built condition of resources match what is in the models themselves. So in this vein, our first panel this morning is going to focus on modeling and planning for an increasingly diverse and variable grid. Those are going to discuss a variety of the variability of renewable generation, the potential for energy storage, talk about aggregated distribution, distributed energy resources, and large flexible demand response, and how these resources are factored into grid studies along with the continued use of conventional generation. The second bucket of recommendations that our report identified is the immediate need for a performance-based, comprehensive generator ride-through standard to replace our current PRC 24 standards. NERC has submitted a SAR on this issue to replace the current PRC 24 with a performance ride-through standard. At the same time, across the street, ERCOT is working to update its existing ride-through standards to implement new ride-through standards based on the IEEE 2800 standards. These local and national activities that are ongoing simultaneously are critical to ensuring reliability. So the first of our afternoon panels, entitled Meeting Inverter-Based Resource Performance Challenges, is going to tackle precisely those issues. They're going to look at the various complex aspects of IBR performance in the industry today, the complications presented by this rapid integration into our resource mix, and all the work that's going on locally, nationally, and among industry to address those challenges. Third, our report identifies the need for improvements to the IBR interconnection process as a key reliability step. And so we'll close out the day on this topic with a panel on fostering a reliable commissioning and interconnection process. And this panel will give varying industry perspectives on commissioning and interconnection for new entities within ERCOT, as well as the challenges faced obtaining the necessary schedules, models, and commissioning. All the stuff to ensure that the resources can get on the grid in a timely and reliable manner. Interspersed with these panels that comes directly from our report, our second panel of the day will focus on securing an increasingly dispersed grid in cyberspace. This is something that's important to us, that when we have these sessions that are focused on operational issues, we don't lose sight of the fact that we can no longer treat cybersecurity and operational issues as separate items or siloed issues. And that's being recognized in the planning process. And I'd recommend NERC's recently published paper on cybersecurity contingency planning in the transmission process as a preliminary guide for that integration between information technology and ops and planning. So the panel is going to discuss this evolution of distributed technologies and the cybersecurity challenges that are associated with designing and implementing the associated devices, systems, and infrastructure on a changing grid. I want to thank all of our panelists for participating today. I also want to thank our two keynote speakers, Mark Labbe from NERC and Jimmy Glotfelty from the Public Utility Commission, for taking the time to make this workshop a success and provide us all with their unique perspectives on all of these important topics. So I mentioned at the outset that the report has 4 categories of recommendations. The final category isn't really based on a panel. It's more of a call to action for us and for you to address these issues. Earlier this year, NERC issued a NERC Alert 2, focused primarily on solar PV owners, and the alert contains a number of recommended actions around inverter settings and documenting and mitigating abnormal performance issues. We're looking forward to industry's responses, to your responses, at the end of this month, and we'll be using those to target our activities in the coming year. Our report also calls for our audit staff, to elevate the risk profile of IBR performance and modeling issues, which we're implementing through our compliance processes. So we're leveraging standards like FAC 1, FAC 2, and TPL 1 to ensure that there are clear and consistent interconnection requirements and that IBRs are being adequately studied. We'll also emphasize that IBRs need to maintain their appropriate voltage and frequency ride-through capabilities as defined in the current PRC 24 standard, even as we're working to develop new requirements. So simply put, there's a tremendous amount of activity that's underway, both locally and at the national level, and we hope that this workshop offers you some perspectives on these activities and a roadmap for all that's going on to meet this challenge. So as Matt said, we've got a lot of ground to cover today. And to get us started on our journey, it's my pleasure to introduce Mark Labbe as our first keynote speaker of the day. Mark Labbe is the Senior Vice President and Chief Engineer at NERC. He joined NERC in 2007 after a 20-year career at the Electric Power Research Institute, and overall has been working in the electric industry since 1979. Mark is the author of more than 100 technical papers on subjects like power system reliability, transmission system planning, power system numerical analysis techniques, whatever that is. He earned a bachelor and master's degree in electrical engineering from the University of Minnesota and attended the London Business School Accelerated Development Program, as well as the Executive Leadership Program at Harvard Business School. In 2012, Mark was elected to the North American Energy Standards Board, and he's appointed to the Department of Energy's Electric Advisory Committee by the Secretary of Energy in 2014. He's held leadership positions in a number of organizations, IEEE, the National Academy of Engineering, among others. I have the pleasure of working with Mark personally through the ERO Operations Leadership Team, and one thing that really shines about Mark is his passion for reliability. So please welcome our first keynote speaker of the day, Mark Labbe.
Thank you very much, and thank you, Joseph and Curtis, for inviting me here today. It certainly is a pleasure to visit Austin finally, post-pandemic. Those 2 years that we all kind of lost in our basements or wherever we were, work bedrooms or wherever kitchens, where we were working. And it's certainly nice to come to 105 degrees as well. I did get our bulk power system situation awareness. Folks sent me a note today saying it's hot throughout the country. It's certainly hot here. And you know, you dodged a bullet here. I almost didn't make it. Maybe good for Curtis more than anybody else, but because the flights were a mess, and I forgot about the whole summer don't fly in the evening trick. You know, always fly in the morning. So they informed me my flight was delayed, and so I was able to get, much to your chagrin, another flight and got here well ahead of time. So anyway, glad to be here, and certainly I'd like to second Joseph's words today around inverter-based resources, especially as they relate to the engineering piece. And I tend to look at things, because I only can think of two things at one time at my age. One is, you know, the engineering, get the engineering right, and that's what we're talking about on interconnections and modeling, making sure that they ride through and support reliability. In fact, it's something we're going to probably need to worry about when we get to distributed energy resources at some point or another too. That engineering is going to be really important. But then the other piece is the uncertainty, which is we're building a lot more uncertainty into the system, and what does that mean when we start thinking about planning for a system? What are the energy limitations that we need to be concerned about, not capacity anymore? And I make that point because of what happened on June 6th and 7th, and I'm sure many of you are aware about the 60,000 megawatts of nameplate capacity of wind, which generated well over 400 megawatts across the Midwestern part of the United States. So that could be a bad day. It wasn't, because it just didn't happen on a critical day. We also see something similar in near Bonneville, where when it's hot and when it's cold, that's when the wind doesn't really generate very much. So of course we have some backup with solar there. And we have backup for solar here too, and that works well until nighttime. And of course, then you have battery storage, and that doesn't work after 4 or 5 hours. So these are things that we need to consider as we look forward and plan this system. And it's a new world, clearly. But how do we get here? Well, I always like to look at history. Do you blame me? I mean, you know, gosh, look at the rust on this old bucket here. But my calendar always starts in the 60s, because well before that, you know, Edison and I were having a lot of conversations, and we thought that really history on interconnection started in the 60s. There's a great book written by Julie Cohen called The Grid, a very complicated title, but it does talk about the history of this grid. It's very approachable. I really commend it to everybody here. And it really talks about how we got here from the 1900s, and how the interconnections were really those of convenience between mostly investor-owned utilities who wanted to ensure that they had that connection when there was emergencies, but they didn't want to compete against lower power, so they would then open the interconnections when things were going well. But it's also a history of synchronism, and then finally overall interconnection, and the benefits of interconnection, but then also the risks that come with interconnection. And that's what we saw in the 1960s. Not only did we see the Mamas and the Papas sing California Dreaming, or the Wichita Lineman by who? Glenn Campbell, right? Yeah, right. I know these are songs that are in your mind all the time. Certainly with our Siri radio, you can live in the 1960s day in and day out if you want, simply by turning that music on. So anyway, but this was also when we started interconnecting a lot of the grid. And those benefits were realized certainly in economics, and certainly reliability, frequency sharing, inertia sharing, But then, of course, the risks that kind of came to fore in 1965, which seemed to really hit the very fiber of the industry, an industry that was very proud of its ability to interconnect. And this is the only interconnected system that has been developed from a non-centralized approach. It's basically a patchwork quilt. If you were to go to France, if you were to go to China, if you were to go to India, you'll see a central interconnection body generally associated with the federal government and maybe tying in with state governments. But we kind of came to this kind of a patchwork quilt way. And you know, as a result of that blackout, of course, a lot of blue ribbon panels and all that got together, and rather than have the government go off and do something, industry said, no, we got this. And they formed a number of organizations, including the Electric Power Research Institute and then NERC, which at the time was called the National Electric Reliability Council, and then over time, North American. And Texas, shockingly, was actually interconnected pre-World War II, and actually during the war, to help power the war industry. And then afterward, after FDR got out, because he was the one knocking heads and putting federal agencies in place for damming waters and rural electrification, then that the interconnection kind of spun off on its own. This is also when we came up with the 1 day and 10. So that gets to our uncertainty, the capacity problem, the copper sheet analysis of transmission, and the forced outage rate of a unit, and the 1 daily peak, because computers didn't have storage for much more than 1 daily peak when you did the analysis. I know this, I did this analysis, so, and it would be lovely to have done an hour by hour, but we didn't. We had a one event. And the view was that, well, actually 1/8 is really the number which Arden came up with back in the 40s, and Calabrese kind of worked on some of this. But the view was 1 in 10, that's what we're going to build to. What are the reserve margins that create 1 in 10, usually around 15% or 10 if you had hydro. And that's the way we kind of went going forward. It became the standard worldwide, in fact. In the 1970s, we saw this build-out of central stations, this economy of scale, multiple ownerships of large generating plants, mostly coal-driven. It's interesting, you know, coal became the reliable, certain fuel at the time of interconnections back in the 20s and 30s. The whole idea was that hydro was more certain than coal, so let us make sure we interconnect. It's kind of surprising how things change there. And that actually power was going to be too cheap to meter. Remember with the nuclear stations and all that. So that didn't happen, did it? So the 1980s characterized by gas reform, the emergence of the gas bubble. There's a lot of gas around. People were building plants all the way up and down gas pipelines. There was a combined cycle turbine, which was very efficient and reduced the overall long-range marginal costs. And there was this explosion in gas investments, almost overbuilt, I think. In the 90s, there was this restructuring, and you know, that's where markets were starting to be developed, and it kind of rolled out of the privatization of a number of organizations that were centrally owned. It's EGB in the UK. I'm trying to think of the one in Victoria, SECV, which was the State Electricity of Victoria. And so the idea of privatizing and then selling off the generation, certain companies hold the transmission, maybe selling off the distribution companies. Many American companies, I would go to London and I'd hear more Southern accents in the expensive restaurants than I heard British accents for a while there. And of course, this was kind of this idea of having more competition, driving down, making efficient these costs on the short term anyway. And the market would provide for the long term. In the 2000s, of course, characterized by extreme price volatility. We also had those wonderful, horrible actually, hurricanes, and there was the 2003 blackout. Now, there was actually a conversation in the 90s about this idea of you know, should we start thinking about standards versus criteria? Because for criteria was this one, you know, N-1, we will run our system to that. There's different criteria the organizations would follow. CEOs would get together and point fingers at each other and say, you're not doing it this way, you're not doing it that way. And that was a terrible thing, and people would go home and change what they were doing. But now, who's responsible for reliability if you have a generating company or a distribution company? So there was this view that there was going to be a need for who does what and make sure they're held responsible. After the 2003 blackout, of course, that became a lot more legislated in the 2005 Energy Power Act, and it created the Electric Reliability Organization, which of course then NERC kind of submitted to, and of course with our partners in the regions who are much closer to the challenges that are being faced on the ground, creates what we call a brilliant model of how to manage reliability in North America. 2010, we start seeing some renewables being built. Of course, it was a hobby before, but now, of course, the rapid reduction in costs, the incentives. You note there's incentives to using electricity. There's incentives for certain kind of renewable energies to be on the system. Not too many incentives yet for transmission and distribution, but I think that's going to be needed as we build out the system going forward. So now we're here today. And our decade is one that really challenges us around how we assure the adequacy of the energy, the sufficiency of the energy, especially during events that perhaps at one time were just kind of a bad day. You know, it's kind of really windy here in Iowa, and then that takes out 16,000 megawatts of wind because it's too windy. Or that cloudy month in Wisconsin that I grew up with, and saying, my mom was saying it's a dreary month, could actually be a kind of a bad month from an energy perspective if you're counting on solar. So how do we manage those kind of events and make sure that we have a firmed up energy system that will deliver energy at the reliability needed, considering we are looking at electrifying the consumer, the commercial, and industrial sectors in this country? How are we going to get there and make sure also it's efficient? I'm sorry about that. I turned it on because somebody was texting me a message. Apologize. So let's get back to the fun things here. So it's not surprising, of course, that this is starting to catch attention of regulators, thank goodness, because it's one thing to set a target. It's another thing to assume that the engineering is somehow going to get you there. And we're basically saying there's some challenges here that we're going to need some time to address. Now, not only are we dealing with extreme weather events, of course, we're also having this growing demand, but also on top of all that, cybersecurity, as Joseph mentioned before. So I would say some of our biggest challenges really are to identify what kind of scenarios, what is going to be our kind of design basis. Our design basis is something like the TPL standards, which talks about being able to withstand certain types of events and avoid the evil three, right? The evil three being separation or islanding, uncontrolled islanding, cascading, and instability. How do we avoid that and for certain types of events? And then beyond that, how do we restore? Simple kind of model, but also a model that we can carry forward now if we define the different types of scenarios, which may be different depending on where you are in the country. For example, you'll see one of the standards that came out on cold weather for the generating plants. We tried to define what cold weather was based on history, because that's the best we got right now. I'm not saying that's the best, because what's going forward, what's the weather look like going forward in a climate-changing world? We're not sure, but at least we have that to kind of hang our hat on. So, and that's certainly a standard that we've been moving forward on with the generating plants. The other, of course, is this reviewing of some of additional metrics that we need to be designing our system to. When we go to a regulator, state regulator, what are we going to tell them about the kind of resources that need to be built and why? Why the incentives are there? How much is needed to ensure that we continue to maintain the level of reliability that consumers want? And it's not going to be just 1 in 10, because 1 in 10 can give you a lot of different performances. If you were to look at here, even in Texas, and you'll see the expected unserved energy as a metric compared to the 1 in 10, and you can see different types of performance, even though you're still holding 1 in 10. So that's an area that I think we need to solve as an industry, and I think we can perhaps look to our brethren in Australia and the UK, maybe a few other countries in Europe that are dealing with the energy constraints. And there's some thoughts about numbers like 2% of your total energy could be an expected unserved energy target. That's what AEMO came up with in Australia. I don't know if that's something that fits for us, but it's certainly something we need to get our arms around. So when we talk to folks, and my view is, put as much renewable on as you want, but make sure that you engineer it right and that you've dealt with the uncertainty. That is to say that you don't just shut down all the carbon emitting plants you can without ensuring that you have enough there to provide the frequency, unless you put grid forming on your storage, and is there for long-term widespread events. And of course, that's why we keep kicking a can on cold weather, because that's certainly been one of the canaries in the coal mine, you might say, of performance of those plants. But my view is until we get our plants staying online and our load forecasts are pretty good, can we then turn to the gas industry and say, no, you get your house in order? Because we, if we keep on kind of coming offline because we haven't winterized and yeah, you know what I mean. So this transition, of course, is something that I think is here to stay. We have kind of 4 pillars we think about in the transition. The addition, of course, of these resources, the no and low carbon resources. Transmission internally here. I know this is a hot topic going outside of Texas. I don't think it necessarily has to be AC. I don't care. The question is, well, how much it makes sense to offset the risks that you're taking on when you have uncertain resources being added to your system. And of course, it goes both ways. How can you help beyond Texas when there is a need for help? And that's kind of been something industry overall does to help each other succeed. Balancing resources. How do you balance this uncertainty that kind of comes up and down over time, have unexpected weather patterns, even expected weather patterns? How do you offset that? And of course, I know that this includes demand flexibility. I guess demand response is no longer in vogue. I found out at IEEE this week, it's demand flexibility. So it will be flexible to support the grid. But then, of course, if you're going to be there and support the grid, you have to follow standards so we know we can count on you, right? Well, otherwise, it's like, oh, they'll be there. Well, no, they're not. Oh, well. So we need to figure out how we manage that jurisdictional challenge that faces us too. And then just overall, an energy supply chain. Where are you going to get your energy from and how are you going to manage it? So, there's a number of different critical questions that we're dealing with as an industry. And Joseph mentioned a number of them. And I'm looking forward to hearing some of the wonderful ideas that we have here from around the country. What are the right reliability goals? What should we be designing to and recovering from? Very much a traditional analysis that we think of as an industry. What's our design basis? What are our study assumptions, the ones that we're used to using all the time? The tools that we're used to using. See, this is some fundamental change here. When I talk about EMT, heads start nodding, people get upset, they rip their shirts off. I don't know how to do it. It'll take decades. We can't be adding this stuff to our system unless we model it right. We know that, right? That's fundamental. So if we don't model it and add it to the system, we don't know how it's going to perform, then we should be adding it to the system. And I know that flies in the face of our colleagues that say, just keep putting it on and close your eyes. You know better than that. What is the design criteria? I mentioned that before. When will we get this infrastructure built? The Memorial Day surprise is that NERC is working with our regional colleagues like Texas RE on transfer capability. And it takes 10 years sometimes or more to build a line because everybody loves to have one of those in their backyard and they fight over, no, I want it here, no, I want it there. So it's going to take us a long time to get some of this stuff built. And in the meantime, of course, we've got to manage those risks until we are able to get those built. How do we build cybersecurity in ahead of time? You'll be hearing some about that as well, to Joseph's point about a robust cyber designed system, so we're not just deer in the headlights as the car comes at us. And so we got to make sure that we're in good stead and not building ourselves into a corner, just like I don't like to see us retying ourselves in a corner. If you look at ISO, what ISO New England's dealing with right now, with Everett, the LNG plant, and should they have it or not, the reason why they're in that corner, that $100 million or $200 million expenditure a year, is because they haven't been building gas pipelines forever. There's a lot of gas in those areas, but they don't build them, so now we're in a corner. We don't want to see ourselves in that corner. What are the resilience tools we're gonna need? Resiliency is gonna be more and more important here as consumers become single-threaded and have nowhere else to go except electric vehicles, electric heat, electric water heaters, everything electric. A bad day is gonna be a real bad day, could even be worse. So how do we make sure that we increase our ability to provide reliability locally as well as long distance? So I know that to address all these challenges, it's gonna take a lot of work with not only the folks here in the room, but also, of course, policymakers and regulators need to come to the table as well. So bringing them together, along with perhaps some industry experts, can help us help them understand what are our challenges and what should we be thinking about designing to. I know that I've talked to a few regulators, and they said they finally started getting it in one place. They said, so what you're telling me is that there's gaps being created by the addition of these new resources, which we're not currently designed to manage. And I said, basically, yes, that's where we're at, and that's something we got to get our arms around. So there's huge investments necessary here. It's a great opportunity to renovate, innovate the grid, and it's going to be people like you all that are going to be able to do that. And it's an exciting time to be in the industry. And that's the other challenge, of course, is getting people in the industry, right? You know, I know there's workforce shortages in many different organizations and sectors, and certainly in this one. Not only just for people climbing the poles and helping us build stuff, mining the minerals that we need to build this stuff, but then also the technical support and administrative support that we're going to need to be successful. So certainly an exciting time to be in the industry. The bridge may be a little bit longer. We like it. I know there are some folks that we talk to that say, you know, I just want this, get rid of it, get rid of all the fossil fuel. I was listening to a station, BBC, and they had this guy on from Shell, and he said it'd be irresponsible. And perhaps those are the right words. Until we have the fusion, small modular nuclear reactor, hydrogen, whatever, dispatchable, firm resource. And of course, I sometimes tease my colleagues in renewable energy. If we have small modular nuclear reactors, we don't need renewable energy anymore, because they don't like that. But you know, it may actually end up being something that's a little bit more affordable and certainly more certain. So I'm delighted to be here today. I'm looking forward to listening to the conversations, and you know, I appreciate you listening and hearing me through. Just think of it in my simple mind, two things to deal with: the engineering, which you're going to hear a lot about today, making sure that we integrate and support reliability in a way in which generation should, resources should, and we always have expected them to do in the past. And then now we have uncertainty, and that uncertainty is mostly driven by wind and solar, weather, cold, hot, and how do we manage that now that we have this far more uncertainty on the grid? Thank you, Joseph, again for inviting me here. Curtis, really appreciate having a chance to chat today, and look forward to learning some more things from Texas. Thank you. Are there any questions? I'm happy to take any. No questions? Control yourself there. All right, thank you.
Okay, everybody, we're slightly ahead of schedule, so we're going to take a short break while we get our first panel ready. So if you could be back at 9:50, please. 9:50. We'll get going again with our first panel of the day. Thank you. 2-minute warning. We'll get going again in 2 minutes.
Does he need to check volume or anything, or on the mics, or?
They'll handle that. Just plan on talking like normal. I mean, they've all been tested and retested, so we should be good.
Yeah, I was looking for some kind of like a timer on these.
I'll
But
be-
you'll just stand up and wave your hands like this.
You'll notice, because like the motion will catch your eye. Okay, it's time to get rolling again with the Grid Transformation Workshop, and it's my pleasure to introduce our first panel of the day. This panel will be on modeling and planning for an increasingly diverse and variable grid. Starting from far left to my right, we have Sirius On from Encore, Dr. Kerry King from the University of Texas Energy Institute, Nick Wintermantel from Astrape, and Robert Golan from ERCOT. And Texas RE's own Brad Woods will be our moderator. Brad, it's all yours.
All right, thank you. Good morning, everyone. As you know and as planners know, the ERCOT system is changing. It's no surprise to anyone. It's changing. Over the last few years, a lot of solar resources and a lot of wind resources have been added to the system. And a lot of wind and solar resources are going to be added in the near future. But unlike conventional generation, these resources don't produce power unless the wind's blowing or the sun is shining. Also, unlike conventional generation, these resources use inverters to produce their AC power. And that's hence the name, inverter-based resources, or IBRs for short. And one of the things that we have to consider with these changes is that, unlike the conventional generation, these resources produce their power, in the last few years, the number of coal plants, I've been working on this for a while, but in the last few years, the number of coal plants has been decreasing, and one of the things that we know is that conventional generation is needed to serve the load. We've got all these IBRs that are being added, wind, solar, but also the number of coal plants is reducing, and we know that conventional generation is needed to serve the load. And one of the things that, because the coal plants are going down, the natural gas resources, the reliance on natural gas resources to serve as load is increasing. Also, the forecasts are showing a large number of batteries that are going to be added in the near future. Okay, so we've got IBRs increasing, we've got coal going down, reliance on natural gas increasing. We've got batteries being forecasted for the near future. A lot of batteries are being forecasted for the near future. We also have DERs. There's a lot of DERs that are forecast to be added. And DERs, what are DERs? Well, DERs are the resources that are added to the distribution system. So what does all that mean? Well, all these changes that are, that have happened or planned for the future, all these changes, that has led to the change in the way transmission and resource adequacy studies are performed. And since that's And because all these changes and so forth, and the changes in the studies, that's what this panel today is going to discuss. This panel today is going to discuss those changes. And I'll start off with Robert with the first question. Robert, based on ERCOT's experience, what types of models and planning studies are needed for IBRs?
Well, thank you very much for that question. First and foremost, the models that are used to evaluate the increase in inverter-based resources need to be compatible and also extremely accurate. When I mean compatible, they do need to be the data that's provided by the resource entities to perform transient stability studies that, again, are needed to evaluate the impacts of these IBRs, needs to be compatible with the planning phase domain PSSE model, the electromagnetic transient stability models, PSCAD, and then also the operations phase domain TSAT software. So all of the data that is provided needs to be compatible with those softwares in order to perform the necessary transient stability evaluations. Now, also, there is an extreme importance on the accuracy of these models. If you don't have the appropriate accuracy of the models, you don't have the confidence in what the actual simulations are producing. ERCOT has proposed and implemented some planning guide revisions, PIGR 075 and 085. This will help enforce the model quality tests that are associated with these data submissions to ensure that the results that are produced from these studies are as accurate as possible. And as far as studies go for the increase in inverter-based resources, the overall system strength of the ERCOT system is extremely important. And what I mean by that is there enough inertia on the system to support single-phase, three-phase, line-to-ground faults on the system? And then also, do we have the transmission capability to transfer all of this new resource to the high-density load areas throughout the ERCOT system? One of the recent studies that was performed was the assessment of synchronous condensers to strengthen the western portion of Texas system. And this did exactly that. It looked at the overall system strength in the West Texas region, looking at voltage profiles, is there enough inertia on the system, and actually recommends adding a number of synchronous condensers to ensure that the appropriate system strength is in place. And then as far as transfer capabilities, one of the analyses that was conducted is the long-term West Texas export study. This is, again, evaluating the transfer capabilities to get these inverter-based resources out of western portions of Texas into the higher density and higher load areas.
Great. And one of the things you mentioned was what I would consider like advanced type studies, like EMT studies. So why are these EMT advanced type studies needed for IBRs?
Well, again, one of the reasons that these are needed is to ensure that you're not going to be in a potential situation where you have grid instability or potential voltage collapse scenarios that could potentially black out portions of the ERCOT system. So again, I go back to the assessment of the synchronous condensers to strengthen the western portion of Texas. That is the type of evaluation that needs to be conducted to ensure that the overall system strength is maintained in these areas where you have large increases in both IBRs and the loads. In West Texas, there has been a substantial increase in the oil and gas loads that are being modeled out there.
And one of the things I mentioned in my intro, which I kind of didn't do a very good job of. But anyway, in my intro, I mentioned the IBRs, right? Inverter-based resources. And that could be one of the reasons, right, that why these more advanced type studies are needed, because they're inverter-based. Is that something you would agree with?
Yes.
Yeah, and I guess also, if I'm a planner, if I'm a planner in a different part of the system, how would I know whether or not I would need to perform one of these more advanced type studies like EMT studies? Do I need to, regardless of where I'm at, do I need to perform these EMT studies?
That's an excellent question. ERCOT, through its annual planning process, conducts various analyses of near-term and long-term evaluations of the system. This would give you clues as to whether or not you have areas that could be potentially impacted by IBRs in your system that might require more advanced types of studies. ERCOT continues to coordinate with transmission service providers, staff with the PUCT, the ERCOT stakeholder process, to come up with any potential new or revised planning criteria that might be imperative to evaluate. And of course, based on real-time events. This might be indicative whether it was in the ERCOT system itself or other portions of the world, situations that they have seen in real time. We need to factor that in and see if that is applicable to any portions of the ERCOT system.
Great. Thank you, Robert. Next question, Nick. With the large addition of IBRs, how has the resource adequacy studies changed for the ERCOT system?
Yeah, and I think Robert kind of managed that question from the transmission side. Certainly, the resource adequacy framework is much more fascinating than it was, say, 10 years ago with these IBR resources. Certainly, wind and solar have changed the dynamics of resource adequacy work. Now, instead of just looking at kind of the peak hour day, as I think Mr. Lobby talked about this morning, we are moving to where we certainly have to look at all 87, 60 hours. And these types of resources have really become, forced us to look at accreditation much more closely. We need to know the accreditation of these wind and solar resources. You'll hear ELCC studies, which our firm conducts pretty regularly kind of around the country. And these ELCC studies, the problem with them is they're always changing. If I add more wind or if I add more storage, the interactive effects of these answers are going to change depending on the point in time of that portfolio. So the studies have become much more advanced because of these resources. And then you also have, from an operational perspective, integration studies that need to be looked at. Will the conventional fleet, as you talked about, Brad, be able to ramp up and down to meet some of these, what I would call net load volatilities that on a minute-to-minute basis that we have to meet now? We may have to ramp a little bit faster, carry more operating reserves to manage these new IBR resources. So it's certainly a fascinating time from a resource adequacy perspective. And maybe I'll stop there.
Well, that's very good. And based on what you've seen from your resource adequacy studies, is the highest risk during peak load conditions?
Yeah, I mean, obviously 10 years ago, 15 years ago, we could look at the peak day, really understand our reliability risk. And wind has partially kind of shifted that, what I call the net peak load, but really as more solar gets added, that's where we really start seeing the dynamics change. For you guys, as Texas has added more solar pretty impressively the last couple years, and as that grows, what we're going to see is that the net peak load on a summer day is not going to be normally at 4 p.m. anymore. The risk is going to shift to later in the evening. As we add that solar, that net load shape's going to peak, maybe hour 18 or 20 of the day. And so we've certainly shifted the risk. As we move out there to later in the day, wind actually typically in most regions performs a little better. So there's kind of this interactive effects with solar and wind. Wind will get a little more accreditation as that solar increases. Winter, generally, we're still going to see that morning peak and afternoon peak. But as all these IBR resources get added and we have these interactive effects, as I kind of said previously, we're going to have to look at all 8760. And it's not necessarily just going to be a capacity constraint anymore. It could be that we're energy constrained as we add more storage. Storage resources obviously have to be charged. So the dynamics, it's just going to take a lot more modeling, a lot more analysis to understand the new risk with the
Right.
transition.
Okay, and my background is transmission planning, so as a planner, I know that for transmission planning, you typically look at summer peak, winter peak. You typically look at the peak load conditions, right? But my understanding is now that maybe the risk for resource adequacy maybe is not during peak conditions. But if transmission planners are looking at peak only in future cases, do you see that as being an issue? And if yes, what is a possible solution?
Yeah, no, that's a good point. I mean, there's always been a little bit of this disconnect between the generation planning and transmission planning that I think all organizations would like to merge. But because transmission planning, it's this detailed power flow modeling, you can't go look at every single year. Whereas on the resource adequacy side, you're not doing full power flow modeling. You can run all 8760 hours thousands of times and get good what we call LOLE results to meet that 1-day and 10-year standard. But to your point, Brad, I think there is a reason to start thinking about looking at more hours on the transmission side if the models can get there. Our Astrape actually a few years ago did a project with EPRI where we were kind of taking snapshots of dispatches out of our resource adequacy tool and trying to let that talk with the power flow tool, kind of send over those snapshots over to the power flow tool, allow for more hours to be looked at. Certainly, it's still challenging. You got two different models trying to talk to each other, but I do think the industry probably will need more of that in the future to look at, hey, hour 20 in the summer, more hours in the winter, and then of course we know planned maintenance is becoming tighter and tighter in the shoulder periods. So certainly some of those shoulder periods need to be examined as well.
Yeah, Sirius, you want to add something?
Can you guys hear me? Does this work?
I think I'll turn it on. Just go.
Okay. So I think I would agree that it's really difficult from a planning assessment perspective to cover too many scenarios of the grid conditions. However, I think it's really important to focus both on, at a minimum, summer peak conditions and also off-peak conditions. And while I think focusing on summer peak conditions is really important because it's very common to see thermal overloading or voltage issues, studying summer peak conditions, and it's much more prevalent than studying off-peak conditions. And those are the issues that we do need to address. However, planning cases that are developed for summer peak conditions tend to have pretty high amount of conventional synchronous generators, and also large amount of motor loads. Tend to have pretty high inertia level. Tend to have pretty good short circuit strength as well. And those are the things that kind of support the grid in terms of frequency and voltage response. I mean, having too much short circuit is all it could be bad, but having enough is it's supportive for the grid reliability. But if you look at off-peak condition or cases that are developed for off-peak conditions, they tend to have less conventional generators deployed, right, and less less amount of motor loads. Tend to have less amount of inertia because of that, and short circuit as well. And I think it's really important to address any issues that you could see from those type of conditions as well. So that's why I'm saying it's very important to cover at least focus very equally on summer peak conditions and off-peak conditions.
That's great.
Especially when it comes to transient stability analysis.
Yeah, thank you, Sirius. And Robert, you want to add?
Yes, I just wanted to say, we agree with your evaluations that, typically summer peak is always the main focus, but the way the grid is evolving, and especially out in the West Texas area where you have more of these constant loads, that would be seen on the system both day and night. We have performed, various evaluations of, high wind, low load days without having that solar capability out in that area. And I would like to just point to both the Delaware and the Permian Basin load integration studies that actually goes through this evaluation to determine what types of upgrades are needed for that system to be able to support, again, the transmission capabilities out of the western portion of Texas.
Right. So there's definitely a lot of different scenarios that can be looked at, right, of what I'm hearing. And that, I mean, there could be unlimited number of scenarios, but you don't have unlimited amount of time, right? So you have to pick and choose exactly, which scenarios you need to look at. And I think that's why you try to look at, the resource adequacy and transmission planning, try to tie those together and try to determine when are the best scenarios to look at.
Yeah.
Carrie, I want to, go ahead.
I was going to say one thing on that. I'm not in sort of nitty-gritty modeling as the other people on the panel here, but the challenge, I think, is to communicate what's being indicated up here. Is there are multiple indicators for multiple reasons. You have low net load or a nadir in the load in ERCOT, and the issue is perhaps low inertia, and that's a reliability concern. So mostly in the public hear the word reliability, but it means lots of things to people in this room, and I think the challenge is to communicate. There's multiple types of reliability. In this case, I'm worried about metric A. In this case, I'm worried about metric B, and in a lot of cases in sort of the environmental and economics literature, they'll represent all these different kinds of metrics in a circle or say, well, how good am I on metric 1? How good am I on metric 2? And you'll see where we are in that. And, what's the risk of low inertia? What's the risk of resource adequacy at peak in summer? Mm-hmm. What's the risk of resource adequacy at peak in winter? So I think, it's a challenge to try to communicate the multiple types of risks that are being analyzed by all the different types of models. It gets lost in kind of the public. If the grid doesn't work, then they said it was reliable, and you're like, oh wait, that was criteria A and B we said we're good, but it was C that we're worried about here.
Right.
And they get confused.
Yeah, no, that's a good point. And also, there's a lot of discussions about IBRs and the different studies we need to perform and look at, scenarios to look at for IBRs. But I want to ask you a question about natural gas. As I mentioned, ERCOT's reliance on natural gas generation is increasing. So how does this impact resource adequacy studies, and what are some of the risks for that?
Yeah, so the natural gas story is, I guess, one of, from a general energy standpoint, success due to hydraulic fracturing and this kind of things from the late 2000s. And as you kind of point out, the absolute of natural gas generation in ERCOT has kind of increased. The fraction of generation from natural gas is roughly constant. If I'm talking, people measure whether there's an energy transition going. There's absolute numbers and there's relative numbers, percentages. It's important to understand both. But the total amount of, say, natural gas, coal, and nuclear has been about constant for the last 20 or so years, right? So all the increasing load growth is from pretty much renewables, and now increasingly solar. So that's ERCOT, I think, benefits from a historical legacy of having a lot of natural gas generation, since there's no hydro here. It's quite, and I think we're coming up with this struggle now. This is kind of I kind of see the ERCOT market of benefiting from the legacy of the integrated utility system, and only in the last 10 years have we really started to see retirements that are occurring. And so the investments now really are driven by market rules, instead of having some legacy plants that were left over from the integrated utility business model. In terms of, I guess, a little bit of resource adequacy, the keynote speaker, Mark, mentioned that maybe the electric side of the equation needs to get its house in order before it tells the natural gas side how to present information. I think as somebody living in Texas all my life, and then thinking about Winter Storm Uri and hearing the responses to that, I think there's still some catch up from the natural gas side to do. Just the data available, right? Going on the ERCOT website and looking and saying, oh, here's what the forecast is, here's what the resources are, here's what's going on right now from wind and solar. It seems like we could get 50% of there from natural gas. Like here's some metrics of pressure on the system. Here's how much gas is flowing. This kind of thing, because as we learned, the peak in the summer is probably more reliably met than the peak in the winter. And largely it's because we have seen, at least in a couple instances now the last 2 years, that the natural gas supply into the pipeline system does go down for various operational reasons, maybe mechanical freezing failure reasons, but also just standard operating procedure reasons of not leaving someone stranded in West Texas in a winter storm,
Right.
working on a gas well. So I think some clarity on that and modeling about what we actually think the natural gas delivery could be. What is the, we have a feel for what the peak electricity generation capacity is, but I don't think we have a feel whatsoever for what the peak natural gas delivery will be. And as we try to electrify more loads in the peak in the winter in Texas, why it might not surpass the peak every year in the summer, when it does hit, as we electrify more loads, it's going to get increasingly perhaps higher than the peak in the summer. And so I think that puts us at risk. We sort of understand this risk, and this gets in, how much demand response does somebody want in a sub-freezing temperature situation is a good question to have. How much can someone prepare in a demand response sense for a few days of rolling blackouts? So I think even just from the natural gas supplies perspective in the winter, the necessity for demand flexibility, if we're going to use that term, to enable rolling blackouts to occur if there is a natural gas shortage that we didn't see in Uri. That was pretty extreme, but I think more demand flexibility for demand response can help. We need a way for, somebody's going to have to say, well, don't run your electric resistance heating for the next 30 minutes so that somebody else can run theirs. How do we make this happen?
Yeah, very good. And for the most part, I believe transmission planners typically look at summer peak conditions, but you're making a good point as to maybe you need to look at winter peak conditions for the future, and maybe the lack of natural gas, generation being available because of the shortage of natural gas that could happen.
Yeah, I think at least the seasonal assessment reports to have a winter and a summer, at least the basis is there to think about the differences.
Definitely something for transmission planners to consider. I'm sorry, Nick, did you have something to add?
Well, no, I agree with everything Kerry said. I just think from a resource adequacy modeling standpoint, you're exactly right. Need to get our hands around what that gas risk is. But if we typically will try to look at historical data for any jurisdiction we're modeling, and maybe you got 5 or 10 years of good data, but you only have 2 or 3 events to look at. And maybe the utility sailed through one event that was really cold, but then the next one they performed poorly. So what do you put in the model? Do you put in that worst case? Well, then all of a sudden it's going to say planning reserve margins need to go up substantially. For instance, Elliott, they think it was public that PJM had over 40 gigawatts out of thermal. Well, if we put that in our model, the PRM's going to, you just can't manage that. And so that's almost more of a resiliency case than a resource adequacy modeling case. So I think from a modeling side, it's a struggle. What do you put in the model? You've got some point estimates that are really extreme. You've got some point estimates that, hey, we sailed through. So trying to get your hands around what to model's a challenge.
Right. Thank you. And Sirius, I want to go to you now. And we've been talking a lot about, resources that are on the transmission, added to the transmission. But there are also resources being added to the distribution, DERs. One of the struggles that a planner has that I'm aware of is that the location and size of future DERs. That's kind of hard for planners to predict and to include in their models. So can you explain to us, how does Oncor forecast DERs for their system?
So as you mentioned, it's really difficult to forecast the location and size among other DER pertinent parameters. But and I don't think there's any requirement for TSPs like Oncor to forecast future DERs, at least today. But we're paying close attention to all the discussions out there pertinent to DER, so we could be ready for any future requirements. But I guess I would imagine one could, look at the past and current trend of DERs and extrapolate that and consider other factors like correlation with, load characteristics to DERs, based on the existing data to forecast future amount.
Yeah, that's what I've seen is I've seen planners look at, well, here's where the growth has been happening over the last few years, and here's the growth that we've seen in those locations. And when you just kind of forecast, you just try to forecast the same amount of growth in the same location. But of course, there's always new subdivisions, new communities popping up where DER can be added in the future that maybe you haven't seen in the past. But yes, it is definitely a struggle. And when you add these, let's say you do decide to add them to your cases, how do you model those?
So in terms of DER modeling, ERCOT and TSPs are continuously discussing how these DERs should be modeled in a manageable manner, and that yields, study results that are meaningful. Mm-hmm. And at least today, those requirements entail that ERCOT models DG resources, distributed energy storage resources, and settlement-only DGs using the dynamic model provided by the resource entity, or if that's not available, they will use a generic DER dynamic model, DERA. And TSPs like Oncor are responsible for modeling the UDG unregistered DGs, the rooftop solar and things like that. But they're modeled as negative load in our planning cases. And Oncor started evaluating DERs in our transient dynamic analysis, stability assessment. And the way we're doing it today, we're taking the base dynamic base cases and adjusting DER models, at least the ones that are existing in the base case, to increase that amount, the total aggregate DER amount in the Oncor area. And we run contingency analysis, just like any annual planning assessment. And we're evaluating any measurable differences between the system performance before using the base cases and DER increased or adjusted in those base cases. Mm. So far, we haven't seen any measurable differences per se, but I would imagine as we beef up the amount of DERs that get included in our planning cases, we'll start seeing some measurable differences, and that's what we're trying to capture, so we can adapt to whatever we see at that time.
Right. Yeah, that's what I've noticed as the struggle is that, today maybe there's not enough DER to really have an impact, but the struggle is trying to predict, okay, well, when is it going to grow enough? How do you predict that growth, and when is it going to be large enough so that it does have an impact, so that you definitely need to start including it in your studies? That's something I'm sure as a planner, I understand that's the struggle. Now, Nick, we're talking about DERs, but how has the growth in DERs impacted resource adequacy studies?
Yeah, similar to what you just said, Brad. If it's a small amount, we typically end up reducing the load in our models. So we'll put in the load net of those DERs. I guess the problem with that is when you get too high enough penetration, you really want to kind of capture those as resources so you can kind of understand their accreditation versus everyone else's. If you've got kind of this fixed behind-the-meter solar, maybe it's providing a little less accreditation than say, single-axis tracking on the transmission level. And so I think that's kind of, from a resource adequacy perspective, what you want to capture. For instance, in California, they have such a large presence of that behind-the-meter solar that we actually do, in their modeling, capture it as a resource. But we've also had years of data to be able to implement that. So I think at some point, you do hit this amount where we'd probably not just model it as a load reduction, but kind of start capturing it as a resource.
In your resource adequacy studies for DER growth, I'm sure you don't look at it at a substation level, right? Is it more of a ERCOT system-wide level, or do you look at, how do you break it up?
Generally, we're usually relying on the client for that data, their expertise on what they expect and see, and I'm sure it comes through from the transmission planning folks that see those individual projects and capacities and try to project that out. So Strape doesn't do a ton of that analysis itself. Robert probably can speak to that more clearly.
Yes, I mean, especially handling DERs, you know, it is a complex scenario with incorporating that into resource adequacy. Excuse me. Like you mentioned, you know, your rooftop solar, your small DERs typically get baked into the load forecast, acting as essentially a reduction in the total demands that would end up being served. But the big challenge is, you know, again, trying to reasonably and accurately assign the capacity contribution for each of the DER classes, so that you can appropriately model these resources in your evaluations. You know, it is an ongoing effort. It has become slightly easier from an ERCOT perspective with changes in policies and laws. One example is the 88th Texas legislature passed one of the bills that, you know, requires the transmission and distribution service providers to ensure that they provide the DER information that ERCOT deems necessary to perform all of their evaluations. And again, this is to ensure that we have the most accurate model and simulations possible.
Thank you, Robert. And, yeah, and, you know, going on forward with, you know, we talked about DERs, but now we also talked about wind and solar and natural gas as resources. I'd like to move on to a new type of resource. Is it a resource or is it a load? Batteries. So what, you know, so as I mentioned earlier, you know, a lot of batteries are forecast to be added to the system. And as a planner, one of the things you have to consider is, okay, a battery can be a resource, but it also can be a load. So that makes, you know, planners have to decide, how do I want to study this? And make sure that when it's a load, you know, the system's adequate. And then when it's a resource, the system is adequate to handle those. So can you please explain how maybe ERCOT is including batteries in your studies?
No, definitely. You know, one of the things, you know, first and foremost, during the full interconnection studies, the FIS evaluations for generation that's interconnecting into or proposing to interconnect into the ERCOT system. For batteries, they are modeled at their maximum discharge and their maximum charging values during the evaluation to see if there is any potential issues for them to be either discharging or charging, acting as a generator or acting as a load onto the system. For most of the planning studies, for all batteries, unless it's a settlement-only distribution generator, and it has over a 4-hour duration, ERCOT will be using that resource, that battery, to dispatch during the peak hour evaluations. And then the opposite is true, that for these battery resources, again, not including the settlement-only distribution generators, but these batteries that have an over 4-hour distribution will be acting as, you know, loads during the min-load evaluations, or, you know, a lot of the non-summer peak conditions. But again, throughout all of our planning analyses, we would be utilizing SCOPF, which is the Security Constrained Optimum Power Flow, to curtail these resources if there are potential reliability issues found in the base cases.
Right. That's just serious. I'm sorry. Do you want to add anything on batteries and maybe how Encore includes batteries in your studies?
Sure. So maybe I could talk about 3 things. You know, Encore, just like any other, you know, NERC classification, you know, transmission planner, have to evaluate the model verification report and also, you know, perform model usability test. You know, that's per, you know, Mod 26 and 27. So we do that, and we also, you know, just like any other TSPs or transmission planners out there, we do annual planning assessment. that naturally include, generators and batteries that meet the inclusion criteria, ERCOT Planning Guide 6.9, to be included in our planning assessment, and we follow ERCOT and our planning criteria to evaluate our system performance, and naturally we get to see the impact from battery additions, and like Robert said, we also do generation interconnection studies, and also that includes batteries too. So in those interconnection studies for batteries, we look at charging and discharging scenarios both, and we run other various sensitivity analysis around it. We also look at other batteries and generators in the study area. We dispatch it at different levels to make sure there's no interaction, and we are able to identify any stability limits associated with the interconnection itself and other batteries and generators in that area.
Thank you. And I mean, that's, what we'll be discussing today is, the changes. And, there's a lot of different changes, a lot of different resources that are being added. We talked about IBRs, we talked about DERs, we talked about batteries. And one of the things that what we also said is, planners have to somehow predict the future. Are we going to have more IBRs? How many? Are we going to have more DERs? Are we going to have more batteries? And all, what does the future look like? Because planners, transportation planners, they have to look, that long term, 6 to 10 years out. So this is where my question. I'm setting this up for Dr. King. One of the questions I have for you is. Planners often need to perform long-term studies, like I said, but one of the things that's hard to predict is the future. We've seen economics kind of, drive, the way things are looking today, the IBRs and things like that. But, based on your economics background, can you give us some information as far as, do you believe, based on economics, the growth that we're seeing now is going to continue?
Well, just to clarify, my actual degrees of training are engineering, so that gives me more street cred in the room than being an economist. But I'm a self-taught macroeconomist, kind of focusing more on the country level kinds of things. So from this one, I kind of maybe think a little bit more from the engineering side about what consumes energy. In some sense, I think of the economy as a big machine. There's a bunch of machines out there, and the economy is putting fuel into these machines to do some kind of a work. And so for new kinds of industries or machines or technologies out there, it's kind of thinking, at least from the context here, thinking about Texas and ERCOT, is this new industry or machine likely or unlikely to be in Texas compared to other places? But we can start with just population. Not going to call people machines yet, but let's just go back to basic population. So Texas seems to be an attractive place for people to still move, even given the temperatures. I think I was joking with someone beforehand. It's like, well, if we see people stop moving to Phoenix, Arizona, maybe that's a sort of a signal that they might stop moving to Texas, but they're still moving to Arizona. Hot, water constrained. So population still seems to be growing here for various business tax types of reasons. Mild winters, except for extreme events. Electrification in general, so it's likely. I think we're close to 40 or 50% kind of heat pumps in Texas, so there's still some way to go there on electrification of heating and of course electrification of cars coming up, and the pilot study here in ERCOT looking at how to integrate cars and batteries as resources. So is that just coming with population? Texas looks to see perhaps a disproportionate share of that, just due to relatively a set of population that can afford cars even in the early sense. So different kinds of industry because of, again, just historical oil and gas, but then continuing to extract oil and gas out of the Permian Basin. This is driving more industry because you're getting a lot of light hydrocarbons out of the ground that are cheap. And so you're driving more petrochemical industry on the coast. So that's something that's not likely to occur in many other parts of the country, but it has been occurring and still likely to occur here. So that's an increased electric load, or at least a gas load if they're self-generating at these locations. For example, in Corpus Christi, now they're having to look at desalination because they're pretty much tapped out on their water resources due to industry and having water transferred from the city to some industries, and so they're looking at more desalination. So that's something that would be likely to occur in Texas a little bit more over time. Carbon capture and storage, in terms of decarbonizing, is that likely to occur here? Texas is probably one of the more likely places for this to happen, whether it's direct air capture and you got Occidental Petroleum out in West Texas that is trying to extend their license to operate from selling low carbon oil. We'll see how that pans out, but direct air capture is definitely a new load. And if there's carbon capture on industrial facilities, that'll require more electricity and heat to run those systems. So that's Texas has the industry and potentially the power plants to retrofit. I'm not sure we'll ever retrofit power plants, but at least some industry. So I think those are kind of the highlights to me. I don't know what's a risk to that if there's a bad drought situation that scares people from being here in Texas, but a lot of the new technologies, decarbonizing and electrification, still point to Texas being somewhat of a center place for these activities to happen. So I think the load growth for 10 years still looks perhaps pretty steady.
Yeah, and the reason why I wanted to ask that question is, that just, as a transmission planner, you have to look into the future, and you have to predict and try to predict what's going to happen in the future. Economics plays into the role of plays into what kind of generation we're going to have in the future, and what the planners need to consider. But today we talked about a lot of challenges that planners have today. We've talked about IBRs, IBRs going up. We talked about coal going down, more reliance on natural gas, batteries, DER. So all these things are, like I mentioned earlier, was the ERCOT system is changing. And the challenges for transmission planning, I think it's getting more complicated for transmission planners. And we talked about all the different changes. But my last question is for everybody here, and I'll start off with Robert, is, after hearing all, after you consider all these changes and challenges, what do you consider to be the biggest risk that you see?
So some of the biggest risks, especially with the change in your typical dispatch, your fluctuation of generation resources, is being able to model, forecast, and of course in real-time operations. Now there is several policy revisions that ERCOT is looking into. One of them does include the resiliency concept in the Senate Bill 1281 that was recently passed. So we are looking to be able to adopt that type of policy into the planning analyses to hopefully better prepare the system for some of these extraordinary events, whether the wind doesn't blow for 5 days straight, or you start seeing these constant loads during non-peak conditions where you don't have solar. Your batteries are depleted at that point, and you might have low wind renewable resources at that time. How do you still serve all of your customers under those given situations? And going away from the typical reliability and looking more into the resiliency aspect of it, of building a over-robust system in some scenarios to help protect, again, always going back to the system strength and the ability to transfer power throughout the ERCOT system. And of course, what you kind of alluded to earlier, with the reduction in coal, the reduction in some of these traditional thermal assets, especially with environmental changes and regulations that are coming, where facilities can no longer meet clean air requirements. There is the potential of seeing a large amount of generation retiring in the near future, and that's something that of course we have to be prepared for. We have to get out in front of, and that is something that ERCOT is continuously working on to ensure that we have that reliable system needed.
Right, Nick.
Yeah, I think you guys may hear a bit of an echo across this panel on this question. But from a resource adequacy perspective, certainly Carrie talked about the load growth, and we're really seeing that everywhere. I think maybe one thing he didn't mention was even data centers. You're talking about adding these data centers that are 90% load factor and coming in big chunks. So we're hearing that a lot across the jurisdictions. But as this load growth, and especially this winter load response with heat pumps, so the resistance heating, we don't really see that saturating at cold temperatures. So from a resource adequacy perspective, this load response just keeps increasing in the winter. And then you've got the thermal fleet that sometimes behaves well in some areas, sometimes doesn't, as it did here in 2021. But then you also think about the frequency of those events. I mean, I don't believe ERCOT saw that type of temperature since 1989. So while we put that in our models, it occurs 1 out of 40 times. Do you really go bulletproof your system for that 1 in 40? I think the answer is what Robert said. Resiliency analysis is now critical to try to somehow work that into the planning. And we've got to figure out a solution for the cold winter peak. Obviously, it can be extremely dangerous situation. And so all that together says the models do need to get better. We need to be better with our resiliency analysis. And then on top of that, you're throwing in, which I haven't mentioned, the dynamics of the wind, solar, and storage resources that are being added, which makes reliability a lot more complex problem. It's very interesting to see how storage and solar can actually help each other, especially in the summer on a system, their interactive effects, I think, as I spoke about earlier. So all that, the challenging is in the modeling, but I do think resiliency, as Robert said, is a key point in this. And I think we're all trying to figure out how to be resilient for that 1 in 40 type event in a manageable way.
Carrie?
Right. As much as, in, handling kind of extreme events like Winter Storm Uri, and people wanted to point the finger at one technology or another that seems to be inherent in what a lot of people want to do. And then people say, oh, it's a system, and people up here are modeling everything integrated as a system as you have to. It's just going to get harder to explain this, and people are going to have more technologies to point the finger at going forward, more reasons, and whether they understand why they're doing it or not. They're going to have more things to point a finger at, and then you're going to have to say, well, yeah, I've got more things to consider in this systemic perspective. But outside of kind of the engineering, one thing that I suppose I was disappointed at kind of the outcomes of Uri was, and maybe I'm just not up to speed on it as much, and I think it would be good to communicate, is if there is kind of an engineering type failure one way or another, or system organization failure, is it okay to have 1 year's worth of natural gas costs occur in three days during an emergency? This is like a big public policy question to me. It's like, we have price gouging laws, natural gas prices rising to hundreds of dollars and millions of BTU kind of fall outside of the scope of the existing Texas price gouging laws. So, during a declared emergency, is this the type of pricing we want? What kind of pricing and cost structure do we want on the electric side and the gas side during an actual declared emergency? And do we want, the equivalent of 1 year's of revenues or costs occurring in a span of 3 days? If it's 1 in 40, maybe you say, oh, well, it was only one. Instead of paying for 40 years worth of gas and electricity, you paid for 41. Right. Maybe that's not so bad. 41, it's within the noise. I don't know what the natural gas price is going to be, but if it happened more often than that, then I think this is going to be seen as unacceptable. I'm sort of surprised that this hasn't been addressed more directly.
Yeah, I think there's a lot of questions that came from that event that they're still trying to answer. And I'm serious. Wrap this up.
Yep. So I was never good at speculating, but I think it's safe to say that there will be more IBRs in the future, and they're mostly based on wind and solar, and availability of them can depend on things that are out of our control. And I kind of worry about that. I think it's important to have good amount of resources, available, whether that's, that are available when we need them, whether that means more batteries or, more synchronous generators. And, it's no secret that IBRs behave differently than conventional generators, and I think it's really important to study them properly using the planning criteria and the tools that are more suitable for IBRs.
Great, thank you. So just to wrap it up, today we learned that there's a lot of changes going on, and there's a lot of changes that are leading to a lot of challenges in planning. So I'd like to thank the panel for very good, very good information. Appreciate it, and I think we are done. Yes. Any questions?
Yeah, we have at least one question. Just a second, we'll get it on screen.
Yeah.
Just a second. In the meantime, that QR code is how you can join Slido to enter any questions, or just, again, go to slido.com and enter TXRE. All right, there we go. There's the first question.
Okay, modeling is one of the most challenging processes because of proprietary nature of OEM data sets. Who wants to answer this one?
Out of my wheelhouse, but I will mention one thing. I was at a conference earlier this year and the administrator of the Energy Information Administration was there, and one of his goals is to revamp the NEMS model, what they call the National Energy Modeling System, where they do their 30-year kind of forecasts and model different policies at the United States level. And his goal is to make it more open source because the model's old and I think written Fortran, and almost nobody can kind of interact with it, but to make it a little bit more open source where people can take the model and make little branches of their own. So it sounds relevant for that kind of issue. I think the detailed modeling this question might be implying is more detailed than what occurs in that type of modeling, but I think the sentiment is good. Yeah, more open source kind of models would be good to help the folks on this panel that actually do it.
Yeah, I mean, just from the working groups that I'm involved in on the NERC side and ERCOT side, I know there's a lot of activity surrounding modeling. I mean, I think for the most part, industry knows that modeling is an issue and that modeling needs to get better, and they're working on trying to address modeling today. There's a lot of activity going on. There's not necessarily anything that has exactly fixed the issue yet because it's an ongoing issue, but I know that there's a lot of work going on to address modeling, and what we see going forward is that modeling is going to get better because of these activities. I don't know if you want to add anything as far as ERCOT's activities, but like I say, I do know that on the NERC side and on ERCOT side, there is a lot of things that are being worked on to try to address modeling.
I'm sure. I mean, as I mentioned in the beginning of this discussion, ERCOT is looking and has implemented planning guide revisions to help bolster the model quality of both the PSSE dynamic as well as the PSCAD models that are utilized, especially if they are the user-defined models that are provided. So that is one avenue of how we are trying to ensure, again, it comes back down to accuracy of your model. If you can't build an accurate representation, you're not going to be able to have confidence in the results of your simulations.
Yeah, so as far as answering this going forward, is improvements are going to happen. I feel comfortable in saying that there's a lot of changes that are happening today, like I say, NERC and ERCOT, and I think improvements are going to happen because of the activities and changes that are being proposed. Anything else?
Thad, any more questions come in?
We do, yes, we've got several.
Do we have time? We good on time?
Give a few minutes.
Okay. Okay, any concerns with DERs being used as black start resources? Should this be discouraged? Question about DERs. Anybody?
So I guess I could take it. Oh, did you want to?
Yeah, I guess I'm not the best person to answer this question because I'm more on the transmission planning side, not on operation side. But yeah, I guess there's some discussions happening about one of the NERC standards, which one was the EOP5, I believe, and that has to do with DERs being included in as a Black Star resource. At a minimum, I think it talked about how DER should be included in any consideration for Black Star. And I feel like it may not be a suitable approach, and I say that because I feel like situations like Black Star would require very precise and focused effort in being able to establish various Black Star corridor. And I'm sure there are a lot of things that go into it. And utilizing DERs that, at least the transmission industry is now, increasing its focus on, maybe a little too premature, is how I feel.
Good. Next.
I think we have time for one more if we have a succinct answer. So I'm not letting you answer it, Curtis.
Oh, 1 in 10. That sounds like a resource adequacy.
Yeah, I could probably take that one. I think I agree, Mark. 1 in 10 has served us well for a long time, but I think there's lots of different groups looking at what should we be looking at going forward. And the systems probably aren't there yet. We're probably next 5, 10, 15 years as we have more storage, more solar and wind. We need to take into account the magnitude of events, certainly the duration of events, because 1 in 10 really just says I'm going to have, whether it's 24 hours or 8 hours on a single day. That's my expectation, 1 in 10. So I think for us, what we're seeing is we need to also look at EUE, expected unserved energy out in the future, loss of load hours, and try to be able to make sure our criteria or those values that we're getting today aren't worsening in the future as we add more and more IBRs. And so I think we're going to have to continue to look at that. And then even kind of max our worst case scenarios need to be taken into account, which falls back into the resiliency analysis. So I think that's all being looked at. I know EPRI has spent a lot of work, a lot of time over the last year or two looking at some of that. So there's probably some papers out there.
Yeah, very good. And one thing, like I say, my background's in transmission planning. The probability 1 in 10, that kind of is not typically added or included in transmission planning events. But heads up is that FERC did send out an order for planners to address extreme winter or weather events, right? And what I've heard and what I've seen is they're considering benchmark scenarios, and that might be where, they want you to plan, transmission planning, they want you to look at a benchmark scenario that involves a extreme weather event. And that might get into that probability of, well, what is that benchmark event that we want to study for extreme weather? And we may get in transmission planning, may get involved in that kind of 1 in 10. What is that benchmark scenario that we want to look at in transmission planning? So that's just a heads up. I think that's coming. Any other questions?
Now, I think we need to wrap up so we can stay something close to on time. Thank you guys for excellent discussion. That was very informative, very interesting, and thank you for handling a few questions there at the end. So we'll take a quick break now while we get prepared for our next panel, and we will get rolling again at 11:05. 11:05, everybody. Thank you. We're about 2 minutes away. It's 11:03, so we'll get going again right at 11:05. So please start making your way to your seats if you're here in person. And if you're online, well, just do what you want.
Five people, there are only 5 people online.
Okay, it's 11:05 on the dot, so we're going to keep this train running on time as much as we can. Real quick, just as a reminder, we will get to as many of the questions as we can, but if you ask a question that we don't get to and you would like an answer, please email it to information@texasre.org, because we definitely want to answer as many of your questions as we can, but obviously the time constraints, unfortunately, we can't get to all of them that come in. So, with that said, it's my pleasure to now introduce our next panel, Securing an Increasingly Dispersed Grid in Cyberspace. We have Stephen Holtzclaw from Enchanted Rock, Jason Christopher from SANS, Christine Sachet from GE, Razvan Robu from Siemens, and Texas RE's Devin Kitchens will be our moderator. Devin, all you.
Appreciate it. Well, first and foremost, I want to say I'm very, very excited to be here today in this capacity, because normally when I'm in this conference center, I'm the presenter, and I'm worrying about the material that I'm going to cover. But today, I kind of get a different perspective and a different chance to ask some questions that I'm inquisitive about. And so before I even jump into that, I just want to say thank you for our guests for being gracious enough to give us your time, your knowledge, your experience. And that's another reason why I'm excited, because you guys are experts in your field. And these types of questions are things I'm really interested in. And it's a little bit more low pressure than normal when I'm in this room. So, I'm excited for that. But the other reason why I'm excited is I get to learn. I get to learn new things, particularly on how the operations and planning affect some of these things. So having that panel first is really helpful. Because moving into this, these are different things to consider with it. These are big risks. But I want to give an overview for the audience listening here in the room and online about what we're going to cover. Probably going to be information technology, operation technology, system hardening, Internet of Things, cloud services, virtualization, that type of thing are going to be themes that we cover, because they're all interrelated with this. And then there's these emerging technologies and what comes with those emerging threats. So very, very excited, good material, and I think it should be interesting. I've worked with some of these individuals in various capacities, so I know they've got a lot of smart and interesting things to say, and I'm eager to get started with that. So the first question we have, I'm going to start off with you, Christine, and then if anybody has anything to add to it, please feel free to do so. So in your opinion, what are the top 3 elevated cybersecurity risks to DER technologies? And then additionally, what controls would you recommend to mitigate those cybersecurity risks?
Well, the first thing I want to say is this is all opinion of me, not representative of my organization. For me, the top threats that I tend to focus toward are ransomware. Everybody's hearing and seeing that in the news and across all the media and all of the publications coming out from government agencies and things like that. Secondly is supply chain. That continues to be a problem for us. And then also just the distributed nature of DERs in general. It's just a much broader, wider attack surface than we've dealt with in the past. And it doesn't necessarily have the same rules and regulations that, say, a traditional utility will have. From a supply chain perspective, one of the biggest things I see is that we are seeing a lot of entrepreneurship in this, which is fantastic to get new players into this. But are those new players focused on speed to market or security to market? So that's one of the biggest things that I feel that needs to be focused on there. As far as the distributed nature of it, DERs are intended to be exactly that. I mean, these can be anywhere all the way down to somebody's home. How do you control resources and protect yourself from resources that are totally out of your control and honestly owned by somebody else? This is also giving us new ways of attacking systems. Traditionally, attacks kind of started from the central nucleus of an organization. Somebody clicked on something in an email and off it went. This is now starting to take, and those would spread out. This is taking a different turn to where you can attack that edge and come back into an organization. So those are some of the biggest things. And plus, with these resources being out of your control, out of your ownership, you have a very limited situational awareness of what's going on with all of these resources out on the edge. Does anybody have anything to add on that?
I will say that the thing with person clicking, this is the social engineering part. And I think it's also one of the major threat, I will say.
Yes.
So this can be solved with trainings. If you train your personnel, then.
So let's shift into controls for a minute. Kind of the big three things for me, and NIST really brought this home for me. Know your network, know what's on it, and know who's on it, and know what the normal performance is or the normal behaviors on your network. So to me, that it really comes down to those three things, just knowing what's going on and what's normal. There are some ways that you can implement controls to help with that. Zero trust is one of those topics that is rising in popularity around knowing that what device and what person is on your network and validating that authenticity of that person and that connection and that communication every step of the way. We're used to having systems designed to where you log in and authenticate once and then you're good and you're in. This is changing that dynamic to where all of these connections going forward and all these communications need to be validated across or along that entire chain to make sure that we're applying the right security and that we know exactly what's going on in our network and that it is from people that are trusted. Because of this edge exposure, you have to treat things as untrusted now because you don't have that same level of control that you had in the past. From a supply chain perspective, when you're doing your supply chain risk assessments, one size fits all doesn't work here. You really need to be tailoring your risk assessments based on the risk profile of that vendor that you're working with. You need to spend some time learning about your vendors in this space, or if you're looking for new vendors, spend some time to really get to know them. What is their methodology and their process for secure by design? Is that something that they're even interested in? Is that something that they're pursuing and following? Learn about their secure development. Do they, within SDLC or software development lifecycle, do they have secure development lifecycle within that and contained within that? And then also learn about their strategy and roadmap for security. Is security even a common factor on their roadmap for their products? If it is not something that is highly discussed with the vendors, maybe you need to think twice about it. Also know what their security oversight is. What certifications do they have? What standards and frameworks do they follow? Dive into these vendors and really learn more and more about them so that you're making wise, informed decisions. And you can't do this just once. If it's a critical vendor for you, my recommendation is that you look at their positioning on an annual basis. Make sure that you're staying current with them. Make sure you're using some of these services that monitor what is going on with them on an ongoing basis. Have alerts with those. If they have something that happened, make sure that those services are giving you notification of the events that are happening with those vendors. And always make sure you're monitoring. Make sure you've got a good consolidated centralized SIM or security information and event management system. Make sure that these events on all of these edge devices are coming into your network and into your SIM so that you know and can continue to build those knowledge bases around what is normal and abnormal traffic and behavior on your networks. Make sure you know that you manage your vulnerabilities. Do your vulnerability assessments regularly. I know that the NERC CIP standards require them, once every 15 months in some cases, 36 months for live. Think about doing them, especially on the edge, a little bit more frequently. Make sure you know what's going on with those devices. If they're out there and they're out of your control, those are your easiest targets. And then also, I know everybody gets tired of hearing this, but patch. Make sure that you're patching. Most ransomware attacks are coming because people have not patched their systems and they've not been kept up to date. And a lot of times it's patches that were released, months to years ago that are now being exploited. Make sure you're patching and just some basic housekeeping there. Make sure you have a good incident response plan. Make sure that you have addressed these kinds of resources in that incident response plan. There's not regulatory requirements to do that for these resources in many cases. Do it because it's the right thing to do, both for your company as well as for your customers. Make sure that you have these plans tested on a regular basis. You don't want to get into an emergency and then try to figure out who do I need to contact and how do I need to contact them. Make sure that you are exercising those contacts with them. Make sure your playbooks are good. There are a lot of really good resources out there that can help you with that, but from a controls perspective, that's my guidance.
Well, you touched on something that you stole my thunder because you actually knew the proper term for it, the secure by design. And I was thinking more the way that I learned it was having it baked in from that software development lifecycle. So with that, I think you bring up a really key point with those entrepreneurs because they're trying to get into the market. From a business standpoint, the focus is to gain consumers, not necessarily the mindset on security. So how is that being factored in? And then these devices are a weak link in this overall process, and how are you going to manage that risk? That's a big challenge if there's not certain standards developed on the life cycle of those type of things, So that's kind of concerning, and even not even related to distributed energy, but where it puts my mindset to is when you think of attacks that maybe even happened on commonplace items that most households have if they've had children, baby monitors, those things, if they can be touched from the outside, are a attack vector or avenue, and like you said, it just expands that threat landscape. So these are, concerning things in multiple ways. So I thought it was interesting how you brought that down to the business side of it too, because at the end of the day, business sometimes drives decisions, and decisions are made based on, what kind of risk tolerance, and that sometimes is a business decision. So I think that's interesting that you brought that into what your, top concerns are when the piece of it right off the bat is security. Well, what's the human factor to this? That's something we're considering too. So I found that really interesting. Did anyone else have anything to add on that? I saw you nodding a little bit, smiling a few times there, Jason. Is there anything you'd want to add here?
I think just tying some of the things together, like when I think of the incident response plan piece, and one of the things that you mentioned was like knowing your networks and knowing who's on your networks. I'd also offer know what your bad day looks like. And knowing that can then allow me to understand where are the gaps that I have in my program, and being able to just really tie that messaging forward. So it's not just having an incident response plan that you have because you need it. I don't like dusty incident response plans, like ones that are active and used and people like know what to do with them. At the same time, if you're having an incident and you're opening up the incident response plan for the first time, you're probably going to have a really bad day. So making sure that you just know what that bad day looks like, because a lot of times it's going to look and feel like a maintenance event. It's not going to look like a cybersecurity event when we're talking about things in the field. It's not the classic 1995 film, The Hackers. I'm not going to have a virus singing row, row, row your boat while it's capsizing ships, right? So understanding what that looks like, I think, is really important. And the only other one that I would add that I think has been really relevant recently is secure remote access. Post-lockdown, post-COVID times, we exploded on having more remote access than ever before. And what used to be a very planful activity became here's a free solution for you. Like, I'm a vendor now, and I can give you secure remote access because you all need it. And what was months of planning turned into maybe days, or in some cases hours, of we have to do this. And so going back and cleaning that up a couple years later is going to be extremely messy, and it's just sort of put the pedal to the metal going forward on that too.
You sparked something. Go ahead, Stephen. I won't forget mine.
I was just saying, to kind of add into the same conversation you were mentioning about ransomware, the other thing too that's actually been a hot topic for us, primarily because we've been trying to figure out how to use generative AI to actually solve some problems that we have in our environment, trying to work through different things. But keep in mind, the same tools that we have available to us to solve problems for the correct purpose can also be used for nefarious purposes. So ransomware is propagated everywhere. It's in the news almost every day at this point in time. But as messages and things get a little bit better, the ability to actually craft a message that's more targeted to an individual and actually use the proper English, proper terms, or proper language, and be able to shape that, the generative AI tools that are out there can help with that part of it. And the other thing that's actually even more a little bit scary is the fact, realistically, you can ask generative AI, if you manipulate the question correctly, to actually have it write ransomware for you. So the folks that were going to having to buy these tools from somewhere on the black market and implement them, they can actually now go use a free open source tool and actually generate the same type of logic, same type of process. So AI is fantastic if you want to use it in the right way, but you have to start thinking about how everybody else in the world is going to use it too. It's not just they're going to say, okay, well, go write me a procedure because you don't want to start from a blank sheet of paper. It's the same concept.
I think one thing that we all have to think about too is, are we going to pay the ransom? I think at some point you've got to make that business decision, and that's a hard decision. And who's going to make that call? Do they have the authority to make that call? What kind of money are you looking at here? I mean, there are lots of things that factor into this. We've all watched over movies and TV over the years. We don't negotiate with terrorists. Well, in this case, you might have to. You might have to really think about that as an option.
Yeah.
And I think that kind of ties in a little bit, especially whether you're talking about an incident response plan. If your IT teams, your cyber teams are the only ones, or even your OT teams are the only one participating in that activity, then you're missing the most important people in your business. You're not interacting with your executives, you're not interacting with your marketing group, you're not interacting with your supply chain group, you're not interacting with all these other components that actually have to dive in to be able to hold hands and work through an event. It's no longer just a singular IT-related problem if your network's down. It's like, yes, you need to go fix it, yes, stuff's encrypted, but how are you going to handle it from a business reputation perspective? Which executive is going to make the decision on, do we pay the ransom, or is it the board, or do we have to worry about who do we have to inform to be able to, for regulatory compliance, things along those lines. If you sit and do everything in a vacuum, it's always going to end up being a lot more difficult on the day that you actually have to do it. So try to make sure that it's a collaborative nature, make sure it's a partnership with the rest of your business, and continue to work to build those relationships internally and have a better understanding of where all of this can actually impact and touch.
I think you bring up a good point too about reputation. Make sure your communications people are brought in, because you want to craft the direction of that messaging. You don't want it done to you.
Mm-hmm.
That's exactly right. That's exactly right.
Well, that's kind of actually, I'm glad you spoke before me, because it went full circle on where my head was, in that I used to do business continuity planning, and one of the biggest pieces was making sure you had the right stakeholders. You mentioned several of those groups, and one of them that we had most importantly was, public relations.
Yep.
Who's going to deliver the message and how can they do so? And then, do you buy ransomware insurance? And also thinking about one step further, your incident response to me is an insurance policy that you're going to be ready to act in the worst case. You don't want a fire in your home, but it could happen. That's why you have homeowner insurance, right? Well, same thing for your business, but that next step further being the tie to your recovery plan. Well, if it goes awry, where's that link? Have we practiced this in a way that we can continue operations, hence the continuity purposes behind it, not just the disaster recovery element, but maintaining operations, because the operations we're talking about are real-time operations, monitoring the grid. So I think those are really good topics to have discussions on, and more organizations should have a little bit of focus there when doing their testing, because from a compliance standpoint, sometimes there are certain elements in there, but it's less prescriptive, which is good. You have the latitude to operate, develop a plan that's specific to you as an organization, but making sure you have the right people there, putting those factors into those plans is in my opinion, absolutely paramount importance.
Also, I would like to add the importance of backups, project backups, PC backups, everything is important. In case of ransomware, it can take you out from that problem.
Absolutely.
Yeah.
Right about that.
Yeah.
And
Always test your backups.
yes.
Sure.
Well, I think that's a good transition into the next topic. And we agreed earlier, I'm going to call him Raz. I'm terrible about pronunciation at times. So Raz, can you, this is a topic I'm really interested in, mainly because there's some SIP components. That's my bread and butter as a SIP auditor. There's elements for SIP 4, SIP 11 for BCSI in the cloud, things like that are coming in the future. January of next year, that's very, very soon. Virtualization, cloud service, it's not prohibited by the SIP standards, but it's not being fully leveraged yet at the moment because there's some challenges there. So thinking about that, and then also this distributed energy resources, the use of virtualization, cloud service technology for data and communication analysis and transmission, it continues to grow, right? And it's within the BPS, the bulk power system. In your opinion, how can organizations implement these technologies in a manner that's secure, efficient, and effective?
So, as you said, this is kind of a future implementation. We are not there right yet because of some challenges, but before going there, we should ensure that our system is prepared for that step. So as per NERC SIP cyber asset that is missing or is degraded or it's misconfigured, it can impact another facility, system, or equipment within 15 minutes. So you don't have time to react. And this can affect the operation of the entire bulk and electric system. So keeping this in mind, we have to program our substations or stations like defense in depth concept. This means we have to have multiple security measures in place. In case one of them fails, we have another one that can back it up, and even prevent or limit the damage that one attacker can do to your system. Additionally, cybersecurity has to be implemented embedded in the product development. It's not enough just after that. So this is really important. And as Christina said, another point, very important factor is supply chain security. This one, you have to do your risk assessment with the external suppliers, transportation companies to see, to analyze and mitigate any risk you might have using their product or services. Mm-hmm. And of course, I will say another important factor is the training. You have to train your people inside your organization. And not only this, if you see that your partners are not doing enough, you should point it out and even offer to train them. Making them safer, it will make you safer. Absolutely. So coming back to virtualization and cloud service solutions, it should be based on three major pillars, I will say. One of them is secure communication. This means you have to have network security in place, one-way communication, authentication. The second one, it will be the data storage. All your data should be on server, secure server that is managed only by the owner of the data, nothing else. And then data privacy is the third one. Make sure you are using encryption and make sure your data is not shared outside of your organization. So in my opinion, the perfect ideal system, it will be if the organization has also in place in the house the cloud service solution. But I'm not sure how many organizations can afford this now.
Yeah, I think that's interesting too with the cloud piece, because ideally it wouldn't be a resource constraint, because there's a cost associated with it, and being able to leverage that but still be secure, finding the balance there. An on-prem solution may not fit every organization's needs, and yes, it's the most secure, which is really where we want things to be. But being able to leverage that maybe for business resiliency, things of that nature, those are big conversations.
I would just say one thing to balance out on that with the cloud is, for some smaller organizations, I would question if on-prem is going to be more secure than some of the cloud solutions. And I think that some of the questions that I have around this, and I'm lucky enough both with SANS and my other work within Dragos to work with multiple sectors. And cloud is already here in ICS and a lot of other sectors. And I don't want folks to get into the mindset of saying no to cloud for one reason alone. We tried this 20 years ago with TCP/IP. We said, no, you will never put TCP/IP in any of our substations. It is too insecure. It's going to add the attack surface. And obviously we won that debate because there's no TCP/IP in any of our substations. No, we lost it. We got trunched. And it was because of the business needs, right? It was this idea of efficiency. And we're going to get more efficient, more visibility. Cloud is offering that on a scale and order of magnitude that we didn't have 20 years ago. So if we as security leaders go back with the same argument of no, we're not going to win that one either. It really needs to be a conversation of yes, and here's how we secure it. The questions I have on that, and I know that we'll talk about this when we get later into training, but do people know what that looks like? The people who know ICS security are in this this bubble over here. People who know cloud security are in this one over here. If you know ICS security, have you gone through and understand what it looks like to have a secure container in AWS? And what does that mean for the resources on that cloud component? Likely not, and vice versa. So I think that the bubble needs to get like a Venn diagram. We need to get some overlap over there to really understand that. But there's some flexibility, I think, more so there, and more lessons learned that we'll have. Virtualization, as you pointed out, I think we've been doing virtualization for a while. It's just the new NERC stuff will have more conversations around terms and definitions that make me a little bit nervous, but we have some experience there. The cloud is wide unknown territory.
Mm-hmm. Well, and that kind of makes me wonder, I know this isn't a question that this is going to be ad hoc for you, but are there any controls that you can think of that you'd recommend for, an organization if they're going that route so that they can make it more secure, so some of those risks are maybe mitigated?
Right, again, because I've seen it in other sectors where they've already embraced it, right? So they may attach some of their, I would say, the crown jewels. So if maybe I'm looking in chemical or pharmaceuticals where they have absolutely embraced the cloud, they're embracing it on the lab management system. So the things that's getting some of the sensor stuff that's going back, so our equivalent of maybe PyHistorian data going back out, they're flexible with how they're treating that, and they'll have a dedicated DMZ, a dedicated segmentation just for cloud, because it needs to be monitored differently. There's a whole lot more connections and access than what we typically see in our Purdue model level 3.5 for the nerdy folks, but the ones that separate us from IT and OT, that's a different DMZ than what I'd look at for cloud. So I see a lot more segmentation there, and actually to the point earlier, I see a lot more specific monitoring there. If I start seeing cloud and OT protocols mixing, do I even know how to look at those differences? And that therefore that DMZ is going to have a little bit different of a focus on monitoring as well.
Absolutely, yeah, that makes sense. I think it's a good transition into what the other piece that you're holding back from talking on, because it's I think something you're going to cover here with this next question is The Department of U.S. Energy recently released documentation on cyber security considerations for distributed energy resources. One of the recommendations focused on skilled and an empowered security team. Can you share your experience or recommendations on how organizations can ensure that we have the right skilled and empowered security team in place?
Sure. I actually went back to the instructor. So again, part SANS, part Dragos, but the instructor in me came out to like, skilled and enabled team. So skilled, do we know that we have those skills in place? Your 1 hour a year SIP training not going to cover it, right? That's not the skills I'm talking about. I actually would like to go back to the bad day. Do you know what your bad day looks like? If you do you know what the skills are to either detect that bad day or prevent that bad day? The mantra that I typically use with OT security teams, industrial security teams, are prevention is ideal, detection is a must. And then I'd caveat that further, detection without response is going to be of very little value, right? Like if I see that there's a fire, but I don't know how to put out a fire, that's not going to really help me out all that much. And so understanding the skills means, same thing I would do as an engineer, right? I'm come from an engineering background. I would do a skill gap analysis. If I'm training an engineer to be able to operate a system, do they know the skills they need to operate? Same thing for cybersecurity. They're now the wrapper of protection around that operator, right? They need to understand operations as well. They need to understand what that bad day looks like. They can't come in there with a pure IT mindset because it's not going to cover what happens in operations. And simultaneously, if I just have an operator and I sort of empower them to do more security, do they have the security expertise to know what that looks like? Right now, again, same like different Venn diagram bubbles. I need to start pushing those together to understand the skills. So I encourage everybody to do sort of like a skill audit, not audit like audit, but like a skill inventory of your teams. Do they know what a bad day looks like? Can they respond to a bad day? Those would be the very first couple of things I would look at. After that, then I could talk about prevention, because again, we've got regulations, we have standards, we have a whole lot of things we could look at there. But if they don't know what a bad day looks like, hey, the RTU is down. Operator may be like, it's Tuesday. That happens. Communication comes in and out. But at what point would you say that looks like a cybersecurity incident? Is it I've lost visibility across multiple sites? Is it I now have loss of visibility inside the control room? We exercise those from an operational perspective, but don't give it that cybersecurity perspective at some time that we really need. So that would be the skilled part. I thought that DOE did a really good job of discussing that in that October report. The next piece would be empowered. Are your teams truly empowered? I think back to when we were first going through NERC-CIP and we're talking about the SIP senior manager, and there were folks who were really looking at what that role could possibly be in industry. And you fast forward to today, and I don't know. In some instances with multiple utilities, they've done a great job of empowering that person. In others, there's probably still a little bit of a lessons learned of this is not just regulation and compliance, this is culture. And I look at it from the same way that I look at safety. When I think of empowerment and safety, every single person in the utility industry has empowerment for safety. You do safety moments, right? You've got toolbox talks, you've got an intranet safety page. Everyone's empowered to improve the culture of safety. When was the last time, and we're getting better at this now, but when was the last time you did like a security moment before a meeting? Or the security intranet page, or talk about the last time you had a security incident? We don't have that same empowerment most of the time. I don't want to say broad pan. There are a lot of rock stars out there that do really awesome things in culture. But that empowerment, when I look at organizations for security, sometimes it'll say, oh, well, the CISO has the empowerment over security. Okay, when was the last time they were working on a conversation in distribution resources where maybe, and I've worked on this, there was a CISO who was alerted when I was having a meeting as an outsider with him on the Department of Engineering was deploying pole top resources that had their own Wi-Fi SSIDs so that you didn't have to climb the pole to be able to do any measurement. You just walked up with your iPhone. Oh, look, it's right there. Okay, cool. He got told after the pilot, like a couple of months before implementation, that this was going to be a thing. So the CISO had no visibility into the OT side. The VP of engineering technically actually owned that security problem. They were empowered to do something with it, but they didn't have the expertise or knowledge, the skills to understand the problem. So where's the visibility? Where's the empowerment? Does the CISO really own it, or do they just own IT enterprise, our email, our SharePoint servers? Do they go into operations? And then the VP of engineering, what do they own? And do they know that they own that? They sometimes don't know that they own that. So skilled and empowered, I think, is a really powerful phrase. And I think that there's a lot of lessons learned across both.
Yeah, I'd kind of chime in a little bit from two different perspectives. One from like a higher level leadership looking down. So I tried it with my teams. There's two areas where I really try to enforce them on and try to help guide. So training and responsibility, growing your skill set is something that as a leader, I encourage my teams and I actually hold them accountable to making sure that they have those trainings and that information that's there. It's my responsibility as a leader to make sure there's funds and money available to go have them take those trainings. But realistically, without the accountability piece, people are going to typically not actually go and do it because it interrupts their day-to-day routine. They're not going to want to go do it, those types of things. So that's one aspect. So I try to make sure of that. And I always have this little clock that's in my head because I remember, and I can't remember the guy's name that told me this, but basically 20% of your skills leave each year. So if you're not refreshing yourself, every year in 5 years, you're basically not going to understand what you need to deal with going forward. So always keep that in mind as you're dealing with your teams and you're having training conversations. They need to be doing this on a much more frequent basis, and you need to be encouraging them for it to go do that. The second thing, we talked about this earlier, was realistically it's a partnership, and it continues to be a partnership. You're talking about a conversation with your VP of engineering and your CISO, and they're not actually understanding what either one's scope is and what they're working on. Security has to become more of a partner to the entire business, just like safety did, 25, 30, 40 years ago when we started understanding that it's not okay that we have X number of job fatalities. So we have to start looking at it from a very same perspective. It's risk mitigation and understanding. It doesn't matter what the type of risk is, but we have to get closer with the business and be able to convey that message to the entire whole of the organization and build a culture around it. And I'm really happy that you said that culture was kind of one of the things that you focus on. But it's risk mitigation and it's understanding and being partner with the rest of what's going on with your company. If you don't, then you're doing everything in a vacuum.
Yeah.
I think this is another one of those where one size doesn't fit all. You have to tailor your training to the role of the individual. You've got to make sure that you're training them on the aspects of security that matter to them, because there are going to be certain topics that, engineering doesn't care about. There may be certain topics that HR doesn't care about, but you've got to train all these people that are involved within your security program as a whole, and make sure that that is relevant to them and not just blast 1 hour course to them that is 90% of it doesn't even pertain to their day-to-day work.
Yep.
Make sure that you're giving them information that is relevant and that they will remember, and do those regular refreshes. Keep those things top of mind. If you have a security incident or an event, use that as a learning opportunity. Get out there and do some more training to help prevent those sorts of things from happening again.
I'm lucky enough to every October get to tour around with other utilities and do the speaking of like, hey, this is Cybersecurity Awareness Month. Have you heard of cybersecurity? And depending on who I'm talking to, I have to adjust, right? Yep. So if I'm talking to the security team, I'll talk about the latest threats. I'll talk about the fancying and the dancing and all the different bears out there and what that means from the threat perspective. But when they then say, okay, well, I want you to talk to the entire utility, and some of these very large utilities, I'm talking to thousands of people, I'm not going to talk about any of that. Instead, what I shift to is a conversation about even their home security. Has anybody talked to you about your router setup? Do you use password managers? Because nobody wants to be the reason the utility gets popped, right? But they don't know. The attitudes or the actions that they do are based off of assumptions and beliefs, right? That it's this culture thing again. And so talking to them about the day-to-day activities changes their work behavior because they understand then a little bit more about what they can do internally. The other pieces of that just sort of spread, I think, from there. Once you can cover the basics, you can sort of have that conversation. And to your point, the role-based pieces are really important. If you're talking to an executive, it's things like, you've heard of spear phishing, well, the whaling, right? Like the people who are trying to get giant checks written that go into an anonymous bank account. Versus an operator, I would just have lessons with them about like, hey, don't plug your iPhone into your engineering workstation to charge it. Like very basic things, but totally different conversations to have based off of their roles and where their environments are.
One of the things you tricked in my mind was when I was doing a lot more training, I would talk to people about how are you protecting your kids?
Yes.
That really gets their interest because that's something that they're very conscious of and very concerned around is those online predators. These are still really good safety practices that you can take back to your day-to-day work, but take that and put it personal to them, something that they're truly treasuring.
No, and I like all of what I'm hearing here. What I found interesting is there's the overlaps from your all's experience, and one thing that I really was curious about, Stephen, for you is, given your position, your role you fill in an organization, how do you continue to build that culture of compliance and security, and what are the types of things that someone could do to kind of foster that in their organization?
So it's an interesting question, and it's one that we kind of deal with. And Enchanted Rock is very special in the fact that we very much value our culture. It's something from the very first day I started to where I am now. It comes up in conversations about how we continue to build. And as we're growing, I mean, we're not a giant company as of yet, but one of the things that's been very important for us is retaining the culture of what we do currently as we continue to expand. So it's something that comes up on a day-to-day basis. And realistically, there's a couple different things that I see that I do that I try to make sure that passes on to everybody else. We're a very open and collaborative company, and that's something where any idea that's brought forward, it doesn't matter which group you're specifically in, is something we try to go back and we vet that with whatever's going on in the environment. You brought up a really good piece about the VP of engineering having an idea. Well, I've got an R&D group that basically their operations is to go and break stuff, figure out what works and what doesn't. And they literally will just iterate and iterate and iterate and iterate. And without actually having that connection into that group, I wouldn't know what they're trying to do.
Right.
Because there are moments when they're going to be like, hey, we're going to go put this Raspberry Pi in one of these gen sets and we're going to monitor it, EGTs, we're going to do all this. Oh, hold on, wait. 1 second, what are we doing? It's like one of those things where you want to try to make sure that you're passing on that knowledge between the different groups. And really how you do that is you go and have a conversation with somebody. We get so tied up in the world of sending text messages and emails and everything else, and it becomes non-personal. So the best thing that I found that makes sure that I can carry the culture of what we do is go have a face-to-face conversation. And don't make it so formal that you say, hey, I'm going to schedule a meeting and we're going to sit down and we're going to talk about this. Because people close off. They think that first off, you're telling them that you're doing something that you shouldn't be doing, which realistically, we really want these people to innovate. That's how we grow as a business. Go just sit and stand there and have a conversation. Just see what they're doing. Get involved in their day-to-day and try to build common ground and have an understanding of what it is they're working on. If it means that you've got to go home and do some research on a specific topic so you understand what they're asking about, then take that time for yourself, one, to grow yourself as an individual, and two, be able to build those bonds and those relationships with the business. And as security leaders or as business leaders, it's important for us to understand the engineering aspects of it, the accounting aspects, the marketing aspects, the safety aspects, the supply chain aspects. And if we don't have a bigger picture of the entire company, we end up with gaps in knowledge, and then we end up with gaps in process, and then that culture doesn't disseminate across the rest of the business. That's the reason why our CEO this year actually has gone and spent a week, a month, basically moving around to different groups and doing the jobs that those individuals are doing. It's something that my COO is very influential in. She goes and she involves herself in day-to-day processes just so she knows what's going on. And it starts from the top down, executive leadership down to the very bottom of the rung as far as somebody that would be just starting as an intern in the company. We try to make sure that they participate in different parts and pieces of the business.
There are two courses that I teach in SANS, ICS 456, which is all about NERC-CIP discussions, and then ICS 418, which is all about building OT security programs. And you hit on notes like perfectly within both. One of the ones that it's a passion soapbox. I'll only get on for like 10 seconds and I'll get off of it. But when people think about the leadership of an organization, and we talk about all the different executive roles, the most recent, whether people acknowledge it or not, is the CFO. The CFO is only been in the nomenclature of business organizations for the past like 30, 40 years. And in that time frame went from like this little bespoke thing taking care of financial risk to like one of the de facto replacements for a CEO if a CEO were to step down. And the reason was this risk management, and they started understanding all of the business. As a financial risk officer, I need to understand every aspect of the business. And my little bit of a soapbox is I think that if CISOs were to embrace that type of methodology, the CISO of the future, like I'm talking about 30, 40 years from now, like not the next 5 years, could become that next de facto for a CEO because we now own all the digital risk for the organization. But that means you need to understand the business and the organization. You just can't put encryption on everything and be like, oh, problem solved. Like you actually need to understand why are the controls in place. And I think that that's one of the reasons we've gotten such a bad reputation in security for the first like 20, 30 years is because we would just put controls in place and not necessarily understand the business need, or the users are going to do X, Y, Z to get rid of my business justification. Understanding that, like I think that's really awesome to be able to hear that integration to the business, like that needs to be embraced more and more for sure.
Yeah, and the users will always find a way to go around what you're trying to do if you don't involve them in your process.
Yes.
Like, that's going to happen. So you may as well just, spend some time and actually build a relationship with them so you can explain why you're doing what you're doing.
Yeah.
And it's also in our nature, our de facto answer is no, right? That's the very first thing that we always want to say. It's like, you want to go do whatever, and say, nope, we're not doing that. But realistically, what you have to do is, in that partnership, in that relationship that you're building, understand why. And then maybe it's not no, maybe it's okay, but, and then we can figure out how to be able best to handle it. And then some of the ideas that come out of that might even influence something else that's going on in the business that had no idea it was there. And you can be a bridge at that point and then continue to further that conversation.
Yeah, that's awesome.
I have to say, you hit on one of the pet peeve topics for me, and that's culture of compliance. I think it needs to be culture of reliability and security. For what we do, that's what the key is. And that security also improves your reliability. And if you're baking this in, like we kind of talked about with Secure by Design, as you're designing your process, bake those pieces into it for security, also bake it in for compliance. So that it's a natural byproduct of what you're doing on a day-to-day basis and how you're doing it. Don't go try to bolt either one of those on at the tail end. Always start up front with those requirements and those objectives and really get people's minds. I think when you say culture of compliance, a lot of people, either they immediately become fearful or they immediately become resistant. And personally, which is kind of odd as a compliance person, really, I don't like rules. So, but I like to put in the right pieces to make people behave and to understand what we're doing and why we're doing it.
When I think for me, it goes to more business courses I took where organizational development and change, it comes with buy-in. It comes on all the points that you spoke to as far as top down. You're not just bolting it on. And when you get the buy-in, you get the why, you have the empowered workforce to execute on this vision. It's easier because if it's just a few folks and they don't feel supported, then it's probably not going to be as successful. Or if it is, it may take longer.
Yeah.
So shaping that and keeping, I think it's easier once it's built. Maintaining is probably a lot easier, but building that's where do you start? And I think, just getting people to buy in, because it's people at the end of the day that perform these tasks. These are machines. There's technology involved, but there's a human element to it. So I found it really interesting to see from your guys' roles how we still have that key element across all of it, right? So that's neat to me. I think I'm going to switch to the next question. I'm going to go back to you, Stephen. Given the rise of foreign nation-state-sponsored cybersecurity attacks, the war in Ukraine, those type of things, could you please share how your organization has implemented or strengthened controls to reduce, risk associated with supply chain, software integrity, and then authenticity?
Yeah, so as you can tell from kind of the conversation here, this is a hot topic because we've already started talking a little bit about supply chain before this question came up. But as with everything else that we do, there's not an individual single answer that fixes the problem. Realistically, it starts from the very, very top part of, once again, building those partnerships and having a conversation. If you're not working directly with your supply chain teams to actually build in process around vetting your suppliers, your vendors, and your subcontractors, then you're missing a gap. You're missing an opportunity to actually have an understanding of how the partners that you've chosen to do business with handle their side of the business. There's tools in the market. We actually rely on a couple different ones. One of them is ISN. They're typically used mainly for safety validation around subcontractors and if they're going to do work correctly or if they have insurance. But as we've continued to grow that relationship with ISN, ISN has actually added additional functionality to do controls and validation on cybersecurity as well as financial. So basically, if you start using these tools as you're vetting individual suppliers or vendors, then you're able to get a better snapshot of understanding where these folks are in the landscape and how much risk you're taking on from the very start of the process. So if you vet your suppliers in that capability, and these tools make it very easy because they go and they real-time update these informations and they ask the vendors to provide backing on data that's here. One of our other partners uses a company called Avetta, very similar concept, right? But it's the same thing. Utilize a tool to be able to help validate and vet your vendors and your suppliers that are going to be brought into the organization. Once you've decided on picking one of those and then you're starting to do an acquisition process on that software, tool, product, whatever it is, go through a modeling exercise. Take that, look at it in whole in your environment, and understand what's going to happen if this one tool or product gets compromised in the middle of it. When we were working with Microsoft for their SJ02 data center project, it was actually really kind of nice. One of the conversations, we did a threat model together as a team, and they used the term blast radius, which kind of just stuck in my mind just because it was one I hadn't actually heard used in that context. Think about if it does blow up, how much mess is it going to create? So start looking at it from all the different risks and aspects from that individual piece of software and start building controls and compensating elements around it. So de-risk your environment. Understand that not if, but when something's going to happen, what does it look like? Understand what's going on. Know your bad day, as you said. And as you get through those things, continue to build that partnership so you've got an understanding of where this product's going to be used, you understand where it's going in the environment, and then start leveraging other tools that can go back and help validate the integrity of the software. That's kind of a lot of the areas that you have there, and then realistically just look at your steps to move it forward. So once you've actually chosen this product, you've gone through your threat model, you understand your controls that are in place, communicate that risk to the business, one, and two, also let the business know what you have to do to make sure that this product isn't going to be an additional problem, and these are the controls we're having to put in place. Once that's done, then go through systems acquisition, install it, maintain it, keep it up to date, do the things that you need to do, and go back and revalidate these decisions as you start bringing more tools or software in your environment. Because each individual component is going to influence how other pieces of software interact. Rights and permissions, back in the 90s and 2000s, everything got administrative rights. You just installed it, it did what it did, it didn't matter, and everybody went about their business. Start looking at it from what do you trust, what do you not. The zero trust architecture is a great methodology to use. But realistically, we've been doing this for a very long time in the IT world. We've always wanted to try to not just open the whole everything up unless we were being extremely lazy about what we're trying to do. So understand and limit the amount of exposure that you have. And that's kind of really it. Start in the very, very, very top, have a relationship with your partners, all the way down through having a relationship with your business, measure your risk, understand it, mitigate it, and then continue to refresh it going forward.
Christine, Jason, Raz, do you have anything to add on that? And if you don't, we got one more, and then I'm sure we'll have plenty of questions.
Very comprehensive. That's,
Yes.
I think the only other challenge that I would note is, especially in utilities, we're a little bit special breed in the fact that when I look at procurement, I look at contracts, some of our organizations are over 100 years old. There aren't many organizations in the world that can say that. And so it's not uncommon to have legacy contracts, legacy pieces that, maybe you've got 10,000, more contracts that you have set up at any given time that have been ranging that span of almost a century. That I think adds that little bit of difficulty. But again, your approach is so comprehensive that it says you add new things and you have to evaluate. And we have real world instances where it's been a concern, right? You look at Colonial Pipeline, that was not an OT-based attack. That was IT where there was dependent systems that you didn't know what was in the pipeline. Therefore, I had to shut it down because I can't guarantee I'm going to get jet fuel or I'm going to get premium fuel out of this segment of the pipe. Ukraine scenario, right? I'll even go to NotPetya. Right? What were the things that all those organizations, FedEx, Mondelez, Merck, all had in common? They were all just filing taxes in Ukraine, right? And so the idea that you could have this collateral damage from how would that tax software lead to an operational shutdown, that's a lot of daisy chaining. That's a lot of those bad days analysis that a lot of us don't think about that you really need to put together as you evaluate your system. So I love that approach. That was very comprehensive to be able to evaluate and understand what those bad days could be and then mitigate from there.
Absolutely. So I'm going to go with the last question so that we can maybe save some time for if we have any questions from the audience. And this is just, and I'm going to go, order left to right as far as, there's left.
That was a good double check.
Last question. Could you share with everyone if there are any other resources, available, to better strengthen, their programs for cybersecurity risk and resiliency for these DER resources?
So in Siemens Energy, we have trainings that we can offer for anyone that is willing to take them under our services portfolio. So yeah, this is one of the things that we are doing, awareness trainings. Yeah.
Perfect. Christine?
I have a list. No. You mentioned before the DOE report on cybersecurity for DER. I think that's a good report that people should get familiar with. NIST has SP 1800-32, which is around securing these resources as well. So that's another good resource for you. Some things to kind of think about. CISA has really good toolkits out there. They have a ransomware tabletop exercise toolkit. Take advantage of those toolkits that they have for security and use those. And then there are a lot of security vendors that will come in and do tabletop exercises for you. You can have them done from ransomware. You can have, and if you feel like you've done well there, why not look next into a tabletop around your backup and recovery capabilities? Mm-hmm. Be able to use some of those resources that are out there and some of these experts that do this on a day-to-day basis. The other thing is take advantage of GridX coming up in November. Use it as a good opportunity to talk about your bad day, and work through your plans and make sure, normally we bring in just kind of, those bulk electric system type resources into that exercise. Start pushing that out to the edge. Start testing what that response looks like all the way out.
Thanks, Christine. Jason?
I had to make a list because you had that list. So the first one, and I think that some of us who are lucky enough to have been in the industry for a while can then remember this one resource that nobody's picked up in a while. One of those, just because we've been circling on the bad days, is the NESCOR failure scenarios. They're produced out of EPRI in 2015. They are 80. They were originally 88. I think they're like the 103 failure scenarios of what the bad day looks like. That includes distributed energy resources. So if you want to look at what the bad day could look like and you've never thought about that before, guess what? Someone's already done the homework. You can go ahead and look at that, and it had inclusive mitigations too. So you could say, this is my bad day, this is the impact, this is what I should do to prevent that. So highly recommend that if you've never thought about this bad day discussion that we've all circled around. That was my first jot down. Another one is SANS, both Rob Lee and Tim Conway produced the 5 critical controls for industrial control systems. If looking at 100 and some odd controls is too much, look at these 5. Yeah. So just being able to look at 5 big buckets. If I'm in OT security, this is what I should do. That's a white paper that's freely available. I highly recommend everybody check that one out. Now, the other one, I would just be able to say, I joke with SANS marketing on this because we have ICS 456, but it says Essentials for NERC Critical Infrastructure Protection. And I'm almost like, oh man, if we didn't have that title, we'd have a whole lot more people in this course. Because a lot of people think it's going to be this compliance-based course. We actually do an entire conversation of how did the Ukraine event take place? And have you work through what it looked like from control center operator to have that event, and then actually apply NERC CIP controls and show you how that would be more difficult if you had those in place. So we do pen testing, we do forensics, we do everything inside the NERC suite. That easily applies to just power system operations. It's just viewed under the lens of here are the NERC CIP requirements that are attached to these very technical, hands-on 20-some-odd labs. And the last part is community, because we talked about culture. We have a really strong and very small but passionate community of ICS security professionals. I'll be speaking at GridSecCon, so that is one place that you can easily plug into the community. But also the SANS ICS summits. We have one in Orlando every June, April timeframe, and actually one coming up in Houston not that long from now, I think in that September. So I highly recommend just plugging into the community, whether it be local CIPSI groups or sort of regional basis, but being able to be a part of it and hear the stories and be able to tell your own, I think that adds a lot no matter where you are.
I'm going to build on what you said. So some of the strongest things that have kind of helped me along the way, well, SANS obviously is one, so I'm glad you did mention that. But 2, the other part is community is a huge piece of it. And I really do feel like, at least for the very beginning, cybersecurity had always been kind of like people didn't want to share information. We talked about sharing information, but it's like almost like you'd have to send somebody to an AA course to be able to get over the shock of actually living through an event. So find time to actually spend with your partners that have actually gone through this and lived these environments, had these bad days, and figure out where you can find those folks. I mean, you're mentioning a couple different ones. There's HughSecCon in Houston. That's where I live, so that's the reason why I know it's there. And also, as commercialized as Black Hat and DEF CON have gotten, they're also really good opportunities to go and learn and see what people are breaking and trying to figure out how things work. Find those different areas, build into that community, and then send folks that aren't always the specific security-minded people to these events, so it enlightens them on what they're seeing and what's going on. Because the more knowledge we pass on to folks that don't live cyber every single day, even though we all really do, it's going to allow you to have more ability to report near misses and things that are in your environment without just having your set of eyes on it. So think about those communities and having that built with folks other than just specifically what we do, specifically cyber related.
Thanks, Stephen. And as far as I know, we don't have any extra questions from the audience at this moment. So, really just wanted to thank you guys again for your time. Really had a great time doing this panel. It was interesting, so I appreciate it. And, I know taking time out of your day to come here is, something that we appreciate, and hopefully the audience gained something from it. And I think sometimes not having questions is a good thing in that they were already
Wowed
answered,
them.
Yeah. So I don't want to keep anyone from lunch, so I think that's all, if that's good with you, Matt.
Absolutely. Great job, Al. It was a very interesting discussion. I know I learned a lot, so let's give them a hand, everybody, please. And before we break for lunch, just a quick note, we will have a slight change to the schedule of the agenda. Our second keynote speaker, Commissioner Glotfelty from the Public Utility Commission of Texas, will be going right when we get back from lunch at 12:40. So just so you know, slight change on the agenda there. But otherwise, lunch will be served in the kitchen just around the corner, and please be back in here ready to roll at 12:40. Thank you.
you.